Hello, everyone. Good evening. Okay, I think we can start. Welcome back. First of all, okay, what's the questions that you did? Any doubts that's remaining? So I guess we had three questions that we wanted to discuss today. One was find a way, maxima, minima, and there was one more spiral order traversal. Yes, so we had three questions to discuss. Any updates? Did you all complete these three questions? Still have doubts on them? Once you tried it out. Done maximum. Okay, great. Find a way, done. Okay, so that's great. Maximum minimum test case failing. So on today I see a lot of done. So I see like I feel that you have tried, at least few of you have tried to do that. So anyways, we'll discuss them and then we can start with strings. Okay, so let's first complete this discussion, then we can go to strings. So here, first thing, let's first question. Okay. So yesterday we ended with find away, right? So let's start from this question itself. Yeah, let's start with this question. Let's discuss these few questions that's remaining, and then we'll proceed to strings. Okay, today we'll start strings. We'll discuss about strings. So I told you, right, strings is little bit special. It's little bit different than the other data types. Like I'll talk a bit about it. Okay, just give me a second. Okay, sorry for that. Okay, let's continue. Okay. Find away is now looking easy as mentioned in portal. Okay, together. So that's great. So let's discuss, right, what are the hints that I gave you yesterday. So I told you, right, think the direction as a variable, right? So you need to just store the direction as a variable, and like you can assume that to be any number, right? So for example, the direction can be any 4 values, right? 0, 1, 2, 3. You can take it a character variable, you can take it a string variable as well, whatever you wish, right? You just have to update in that particular way. Okay, so Now, for example, when you're moving, so let's say you initially start by moving in this direction, right? We start by moving in direction east to west. When we take a right turn, right? Sorry, we start by moving from west to east. When we take a right turn, we start moving towards south. Right? Yeah. So now let's say we are moving from north to south, and then we take a right turn, which will start moving towards west. Okay. Now let's say we are moving towards east to west, and we take a right turn, we'll start moving towards north. Okay. Now finally, if we are moving towards from south to north, we take a right turn, we'll start moving towards east again. Right. So the cycle completes. We start from west to east, and then we take a right turn, we go from north to south, and then if we take another right turn, we'll start moving again towards north. If we take another right turn, we'll again start moving towards east, which is like all the four directions. Let's say this is represented by the value 0, this is represented by the value 1, this is represented by the value 2, and this is represented by the direction value 3. Now depending on the direction value, it tells you which direction you are currently moving and where you have to change. Okay. So let's say we are in this matrix. We don't know anything about this matrix. What's the value that's stored? We figured out how we are going to change our direction, how our direction is going to change. Okay. So let's say we start with two values. One is the row 0, one is and the column 0. So basically we are at currently row 0 and column 0, and we'll start to like move in a particular. Okay, sorry. Yeah. Do we start? Yes, we'll start. I'll just take like 1 hour to complete these 3 questions. Then we'll start with strings. Okay. Okay. So we start with two values. Row and column are 0, right? And then we initially check. What's the check that I told you? When will our loop end? When will we say that okay, we have like moved in one direction, we have come out of the matrix. So if this row and column index becomes invalid, right? So this will point to any direction. So for example, when we are in 0, 0, the next row and column index would be this. Row would be same 0, and the column would update to 1 because we moved in the right direction. We are moving from west to east, so we moved from that cell to this particular cell, right? So until we are within the matrix, we are fine, but somewhere we'll come out of the matrix, that's for sure, right? If all the values are 0, then we'll move in a straight line and we'll come out from this end. So there is some place where we'll definitely come out of the matrix. Okay. Now what our row and column values will be? Anyone figured out what is our row and column values going to be when we come out of our matrix? So if we come out of the matrix in this particular question, we are coming out of the matrix in the straight line, which is outside this. So how would the row or column vary? So what's the condition that you need to check? How will you know that we are outside this? So the row would basically either become less than 0. If the row is greater than or equal to 0, we can keep on running this loop. And row is less than n, right? Which is the total number of rows in the matrix. Okay, let's take it this. Let's say n represents the total number of rows and m represents the total number of columns. Okay. Now, so it will be greater than equal to 0 and less than equal to n, and j should be similarly greater than equal to 0 and j should be less than m, right? Okay. Okay. So we got row and column values. Now finally, okay. So now we got that if this condition is satisfied, we'll keep on running. We'll try to check in which direction we are moving, and accordingly we'll update. If this values has become like outside of this matrix, either the row becomes less than 0, or the column becomes less than 0, or the row becomes greater than n, or column becomes greater than n, right? Okay, sorry, j, not, it's not j, it's column. Okay. So either the row row becomes an invalid value, or the column becomes an invalid value, will end there. Until both of them are valid, we'll keep on running this logic. Okay. Now how do we take it? How do we update it? So initially it is given that we start with 0, 0, and we are moving in a direction 0, right? So initially it is given that the mouse is starting at a matrix 0, 0 and moving from left to right. What is left to right directions? West to east, right? So we can simply call it as the direction is 0, right? As per our convention, left to right, west to east is a direction 0, north to south is a direction 1, east to west is direction 2, and south to north is direction 3. Okay. Okay. We can also take an infinite loop. How we can do that as well. Check the condition inside loop, or we can do it here. Now there will be two cases over here, right? So the first case would be if row and column, the current row and column value that we are on is 0. Yeah, this will be the first case. And the second case would be, it would be 1, right? If it is 0, or else it would be definitely 1, right? Either it is 0 or it is 1. There is, the matrix only contains two values, either 0 or 1. Okay. Okay. Now what it has told, right? Let's read through this. So if we keep on moving in the same direction, if we get 0, and if we encounter a 1, we take a right turn and also change that value from 1 to 0, so that we don't end up in a cycle, right? So if we don't change it, we might end up in a cycle where we'll go from right 1, we'll again take right turn, we again take a right turn, we again take a right turn, we end up in a cycle. So in order to avoid that, we'll change it to 0. Okay. Okay, let's firstly talk about this. So when we are 0, we don't have to do anything on this, but when we are on 1, we can simply update it to 0. If we ever reach 1, well, first thing we need to do is update it to 0. We'll also figure out what we need to what do we need to take turn or not. Okay. Now see here. So when the row and column value is 0, that means we don't have to take any right turn. Whatever direction we are moving, right? We just have to keep moving in that direction. Initially, we'll be moving from west to east. If we have not taken any right turn till now, we'll still be moving in the direction west to east. If we have taken any right turns, we might the direction might have changed, and we might be moving from north to south, or like if you have taken multiple turns, we might be moving from east to west or south to north, right? Any other direction. So you have to check that. So let's say if the direction is 0 and we are moving from west to east. So what we have to do in this situation? How will our row and column index update? So let's say you are here 0, 0, and we are moving in the direction west to east. How will our this change? So we remain in the same row, and the column should increase by 1. Yes. So we just remain in the same row. We don't do anything with the row index. We just increase our column index by 1. We are moving towards right. Achha. Else if the direction is not 0, if the direction is equals to 1, how do we update one column in this case? So if the direction is not 0, direction is 1, that means we are moving from north to south. So north to south, what should be changing? So if you are moving from, let's say, this one to this one, what is the thing that you should change from this particular value to this particular value? If you are moving from top to south, your row will increase by 1. Column remains same, and your row index increases by 1. Okay. Else, if your direction is equals to, let's say, 2, in the direction to which direction we are moving from east to west, right? East to west. So we are moving from, like, say, this 0 to this one. So how should your value change, row and column? Your row remains same, your just column decreases by 1, right? You remain in the same row, just that your column decreases by 1. Else, finally, if the direction is, if it is not equals to 2, then it is definitely going to be equals to 3, right? We have just 4 direction values. We are not going to change anything beyond it, right? So now if you are moving from south to north, that direction should be decreasing by 1, right? So sorry, row should be decreasing by 1. Okay. See, if you are moving from south to north, if you are moving from this particular index to this index, so your value should be decreasing by 1, your row index should be decreasing by 1. Okay. Okay. Now tell me, everyone understood this? And this is again same logic I'm going to repeat in the lower one. If it's not always column plus 1, if 0, no, it's always going to be column plus 1. Check for any place, right? Let's say if you are any place, let's say if you are over here, okay, and we want to move to the right index, so it is column plus 1. If you are over here, you move to the right index, column plus 1. If direction is different, then we have handled it differently, right? If direction is 0, then only we'll increase it by 1. If direction is 1, then we are changing, we are building row and column separately. So only one of these conditions will satisfy, right? Only one of these conditions will execute out of the 4 conditions that we have written. So for A of ij, like A of row column, for any A of row column value is 0, only one of these conditions is going to satisfy, right? Inside this nested if, only one of them will satisfy, and we'll just update either row or column in only one particular way. Only one value is going to get updated. Either we when we are in the same row, we move to the next column, right? So either we do this. So let me clear this out. Either we are on the same row and move to the next column. Either we do this when we are moving from east to west, sorry, west to east. If or let's say if you are, which is this column plus 1, okay. Or else if you are moving from north to south, let's say from here to, let's say from here to here, north to south. So we remain in the same column, but we increase the row by 1. So that is this scenario. If we are moving from, let's say, west to east to west, so it's in this direction. So which is this. So what we do, we are in the same row, but we decrease the column. So we decrease the column by 1. Now the last scenario, if you are moving from south to north, so let's say if you are moving from here to here, which is south to north, so like we are remaining in the same column, just the row decreases by 1. That's it. Okay. So understood how we are moving within this matrix. So see, in order to move to any adjacent cell, right? Adjacent cell, if you know in which direction you are moving, you just need to change one particular value, row and column, and you will be able to move it, right? So that's what we are doing, right? We're just moving to the adjacent cell. Now, if direction 4 will never be equal to 4, right? That will handle. So direction initially 0, we have never updated it. So till now it is always going to be 0, right? Now, when will we update? When we'll see a 1. Okay, so we'll never update it in such a way that it will become 4. Okay, we'll not do that. Okay, let's check. So now let's talk about this. Okay, let's see this again. So now when the direction value is 1, what we have, sorry, when the row and column index value is 1, what we have to do? So first thing that is told in the question, we have to change it to 0. This is already mentioned in the question. Why it is mentioned? Because we might end up in a cycle, right? So otherwise you might end up in a loop, and you might keep doing the same thing, and this would be an infinite loop, right? Okay. So in order to avoid that, we just mark it as 0. Now, okay. Now let's say if we got this value as 1, and we are currently in the direction 0. Our current direction is 0. Okay. Remember, I am talking about the current direction, not the updated direction. We got a 1. Okay. Okay. So let's say we are moving in this direction. Firstly, we updated this. We came over here. Now the current value, so row is equals to 0. Column is equals to 1. We got a 1 over here. Row and column values are like A of row column is 1. Now our current direction is 0. What we should change it to? So after taking a right turn, what it will become? It will become moving from north to south. Which direction value represents north to south? Direction value 1. So we should update our direction from 0 to 1. Okay, this is the first thing that we should do. So that that means we have taken a right turn. Okay, look here, the entire logic of right turn is this. So if we are moving in a direction west to east, and we saw a value, we saw like value that is present over here is 1, that means we need to take a right turn. Now when we take a right turn, our direction would change from west to east to north to south. So this will change our direction from 0 to 1. That's what we have to do. That will simply change the direction. Now, okay, so just do we just need to change the direction? No, we also need to change the row column. So after taking a right turn, we'll come over here. So to store this value. So how do you need to update? What's the thing that you need to update? So we remain in the same column, but we change the row. So how do we update the row index? So we'll be updating the row index by 1. So row index increases by 1, and the direction changes from 0 to 1. Okay. Now tell me, understood this concept? So this direction equals to 1 is changing the direction, and row plus 1. So we have updated now in a different way. See, earlier when we were moving in direction 0 and we saw value A of ij was 0, so we kept moving in the same direction. We updated the column, right? We were moving from west to east. We just changed the column that go to the next cell, right? Here what we did was we took a right turn. Now due to taking the right turn, what happened was we remained in the same column, but row increased. So we changed the row now, and our direction value we changed from 0 to 1. Now the direction in which we are moving is this, until we see another one. If we see another one, then we'll again change our direction. That is, we'll take right from whatever the current direction is. If we don't see a one, we'll keep on moving in. So let's say if this value is 0 and the bottom value is 0. So we don't need to take any more right turns. We'll keep on moving in this direction. We'll come out from here. Okay. Understood? Understood this part? and this is the entire logic. Now, like all the other part is just handling for all the other directions. Yes. Okay, direction will not become 4. Okay, don't worry, let's check. So we have changed the direction from 0 to 1. What if all are zeros? We'll simply move in the same direction, we'll come out from here. If we'll keep on moving in the first row, we'll come out from the first row itself. Okay, this else part will never do. This first row is equal to 0, we'll keep on increasing column plus 1, column plus 1, column plus 1, and come out from the like first row itself. So this would be the last cell which we have to print. Okay. Acha. Next, what will we do? Okay, this did not get row is equal to row plus 1. What did we do over here? So see, take it this, just listen to the solution once, then you will get to know that how like and you can check whether you wrote the solution clean or you can where you can clean it up, right? Okay, just okay, first see the solution and then you can revisit your code. So let's see what we have done over here when the direction is 0. Okay, simple question. This question is very simple. So we were moving in this direction, which was west to east. If the value is 0, we'll keep on moving in the same direction. Okay, how many of you did not get any idea about this concept of direction that we are updating our row column? Any idea? How many of you did not get anything about this? Yeah. Did not get the else part. Okay. Little confusing. Okay. Chalo, fine. Okay. So let me revisit this part. You will be able to understand easier. See, what we need to do. See, what we need to do is so this part is clear, right? We have direction that represents the direction. Okay? Direction value can be 0, 1, 2, 3, and this represents the 4 direction. Yes, is this part clear? So basically, if the direction is 0, it means we are moving from west to east. If direction is 1, we are moving from north to south. If direction is 2, we are moving from east to west. And if direction is 3, we are moving from south to north. Okay. So now is it clear what does the 4 direction values represent? What are the 4 direction values representing? Is this clear? Yes. Okay. Anyone having doubts on this one? Okay. So you have 4 direction values. Now, depending on which direction you're moving, right? Either you keep moving in that direction or you take a right turn. There are 2 choices, right? Either you keep moving in that direction or you take a right turn. Now, when will you keep moving in the same direction? When will you take a right turn? So if the row column, like if the current row column that the mouse is on, if that value is 0, it will keep moving in the same direction, which is the first case that we handle. So if the current A of row column value is 0 and we are within matrix, right? So we initially started with 0, 0. We checked whether this row column value is within the matrix, within the bounds of the matrix. Row is greater than or equals to 0 less than n, column is greater than or equals to 0 less than m. Whether we are within that bounds of matrix. If we are, and if that particular cell value is 0, that means that we are within matrix, the current value is 0. We don't need to change the direction. We just need to keep moving in the same direction. Now, we might be moving in any direction, right? We earlier, so like initially we started with west to east, but we might have saw 1, we might have changed the direction and then we see only zeros. Or we might be moving in this direction, or we might be moving in this direction, we are simply seeing zeros. So how do we handle these scenarios? So we may be moving in any direction. It doesn't matter in which direction we are moving. We'll check. If you are moving in direction 0, what is our next row column? If you are moving in the direction 1, what is our next row column? If you are moving in direction 2, if you are moving in direction 3, what is the next row column value? That we just checked. Okay. I'll explain one of them again. So let's say we are moving in the direction 0. Okay, that is this direction. So if you are moving in this direction, this is the current row column. What is the index of this? So this is 0, 0, and this is 0, 1. How does they refer? So since the row index is same, you are moving in the same row, the column index is varying. So what did we do over here? We just increase the column index by 1. That means if we are moving in the direction 0, if the row column index value is 0 and we are moving in the direction 0, we have to just change the column index by 1. Okay. If we are like row and column value is 0 and we are moving in direction 1, which is north to south, we just have to change the row value by 1, increase it by 1. Okay. So we just wrote key. So there are 2 checks, right? Here we are doing 2 checks. See, first is the while check, which is ensuring that if we enter into this while loop, we are within the matrix. Okay. Now within the matrix, this row column exists. Now, whatever is the current value, Based on that, we'll make a decision. If the current value is 0, we maybe will keep on moving in the same direction. If the current value is 1, we may take a right turn. We will take a right turn. Okay, and that is what we are doing over here. Now, what is the else part? So if part is clear, if part is easy. Understood the if part, everyone? Anyone doubts on the if part? This one. So this is a nested if, right? This inner if is like nested within this outer if. So the outer if the value is 0, we check the direction, we keep on moving in that direction, and we update row and column according to that. Okay. So the next iteration, we are in a new index. Okay, we just don't check that same index again. Otherwise, this loop will never end. Right. So we always need to move to a new index every iteration of this loop. So every iteration of the while loop will move to one new index. Either it be like in the same direction, or it might be in the like direction by taking a right turn. Okay. Clear? Now let's move to the next part. So here, when the direction value is 1, we have to do two things. Take a direction value when it was 0, our work was easy. We just have to keep moving in the same direction. There was nothing else. So if you are just moving in the same direction, you just update the row column index value. Okay, that. But when the direction value is 1, so for example, when you move from here to here, you saw a direction value 1. Now you have to do two things. One is take a right turn. So there is two steps. Take
Hello,
right.
sir. Sir,
Yes.
in the else part, why sir we reinitialize a row and column equal to 0?
Okay, I'll just cover that. Okay, so we okay, let's just ignore this for a second. Let me complete this and I'll cover that why we have done it. Okay, so we first take a right turn, and then we change the, like, we also like once we take a right turn, we go to the new cell, right? We figure out the index of the new cell. Okay, so there are two things that we need to do. Okay, now the right turn is very simple, right? So right turn I already gave you. So you already know the directions, and there are only 4 possibilities that can be there. You are moving from west to east, you take a right turn, you start moving from north to south. If you are moving from north to south, you take a right turn, you start moving from east to west. If you are moving from east to west, you take a right turn, you start moving towards north. If you are moving from south to north, you take a right turn, you start moving towards east. These are the only 4 possibilities. You cannot create a new possibility. You might be moving in any one of those 4 directions. If you take a right turn, like one of the other directions will become. So if you're moving from moving in the direction 0, you start moving in the direction 1. So that's how I updated it to direction 1. If you're moving from west to east, I start moving from north to south. Which value represent north to south? 1. So I changed it to 1. Okay, now our direction changed, so that the next iteration, whenever we are like whenever we are like so doing the next iteration, we are moving from north to south in the updated direction. Now, just this update will work? No, we also have to move to the new cell, right? So I told you every iteration of while loop, we have to move to some new cell, right? So right now we are in this particular cell, A of which was 0, 1, right? This was the cell that which we to move, which we to which we moved. Now, after taking a right turn, which cell do we land to? We land to this particular cell, which is A of 1, 1. Now, how does this differ? So we are in the same column, the column index is same, but the row index is differing. So our row index increases by 1. That's what we have done, increase the row index. Understood? So we took a right turn, we moved to a new cell. Both the operations done by these 2 steps. Okay, understood? Achha. Now the last question, why is this we are updating it to 0? Why don't we leave it to 1? See, so it is even mentioned in the question explicitly, but see. So what it has told that it when you see like take a right turn when you encounter a 1 and change the direction from 1 to 0. Why it has asked? Otherwise we might end up in a cycle, right? So how we might end up in a cycle? So let's say like you take right turn, so you are moving in this direction, you take a right turn, you go towards this. Then you take a right turn, you will go towards this, and you again take a right turn, you go towards this, and you will end up in a cycle, right? So this will never end, like this will always be true. You are always within the loop, and you will just keep moving in a cycle. Okay. So in order to avoid this, you just update it to 0, so that now what would happen is, okay, now how it would change this logic. So now you're moving in this. You saw 1, you took a right turn, but you also changed it to 0. Okay. You saw 1, you took a right turn, you changed it to 0. You saw 1, you took a right turn, but you changed it to 0. This is 0, this is 0, this is also 0. Now, if you come back here, this was 0. But now when you start moving in this direction, here you don't see a 1, you see a 0. So you keep on moving in the same direction, you come out of this loop. You kept on moving in this direction, you did not take the right turn for the second time over here. Understood? So why it will avoid that cycle? So now since it is 0, you will keep on moving in the same direction. You will not take that right turn. So just to avoid cycle, we have done this. Okay. Okay. It will pass actually. So this is like, so this would happen not in case of matrix, but in case of multi-edged graph, this would happen. So you might get the same question in case of graph where this would happen. Here it will never happen. Why? So in case you forget to do this, right now all the test case would pass. The reason being C. So why this pass? Let me also cover that part. So that is interesting. So this is like you can observe this. So for example, let's say this is 0. You start moving in this direction. This is 1. And let's say you don't change it. Okay. So start moving in this direction. It is 1. Okay. Now you start moving in this direction. It is 1. Okay. Now you start moving in this direction. This is 0. So you won't take a right turn over here. Right. So you'll keep on moving in the same direction. You'll come out of this matrix this way. So you're anyways going tangentially. Right. So you will never like here there was 0. Right. So you will never do a right turn over here. Right. So you'll move out tangentially. So entire point was like you should get a 0 in the cycle. And if there is at least 1 0, you'll come out tangentially. And that will always be there. Right. So for example, you cannot have, let's say, we'll say ki what if sir we have only ones in the matrix. Okay. So you can test with all the ones, you will not end up in a loop. Even though all the values are 1, it is very difficult to form a loop. See, you take a right turn over here. Okay. Here you again take a right turn, you come out of the matrix. Okay. Now, so here you were moving in this direction. You saw initially the first value itself was 1. So you took a right turn right away. Here you again saw 1, you took a right turn. Okay. So let's say, okay, let's try to make some other combination. You can try this as much as you can, but I don't think you'll succeed to find this out. Now you move this direction, you see 1, you take a right turn, you take a right turn, you take a right turn, you'll come out from. So basically you won't end up in any loop in this scenario, specifically when this is represented in form of matrix. This would come when you see the scenario, it is represented in form of graph. There it would, there you would end up in a scenario where it might be a loop. Okay. Not getting. So graph part, graph is like different graph. There can be multiple edges. So like it can still result in a loop, right? So graph is little bit different than this matrix. So in matrix there is no multiple edges, all those things. So because that will study in a depth in graphs concepts. So don't worry on that, right? So that is like not for now, right? So that is graph is like the very last topic that you learn. Graph too hard? No, it's I don't think it's too hard. Like see, the easiest thing in graph is you have like only 4 or 5 algorithms that you always have to learn. That you always have to run. There is no new algorithm that you're going to develop. Okay, there's always 4 or 5 algorithms that you have to run. Apart from that, like if like all the hard questions are from those 4 or 5 algorithms. Apart from that, all the other questions are very simple. It's like just BFS or DFS. Okay, so that is just either you do breadth first search or you do depth first search. Your solution is right away. If you get a graph question, either you have one of those 4 or 5 algorithms to run, okay, which can be, and that problem statement is also fixed, right? Either you will be asked to do this, the wording might be different, you exactly will able to get, okay, this is the thing that I have to do. Or otherwise, there is only 2 choices that you need to do, either BFS or DFS. That's it. Okay. So my Microsoft last round interview question was graph. Yes, my last interview, last question, last round was graph. I remember that question. It was, yeah. So you are asked, but the best thing is you have a limited set of algorithms to run. So that makes your life a little bit easier. Okay. Even though like storing it and all things are tricky, but question solving wise, it is always very easy. Okay, now coming to this, when you have direction as 1, so what we do over here, so direction was moving as 1, so let's update the direction. Let's first update the direction. Let's do this over here. So direction was 1, so we are moving in direction north to south. How do we change it? If we are moving from north to south, we start moving from east to west, which is direction 2. So we update the direction. Now next iteration will start moving from to direction 2, which is east to west. Okay. And how does our row and column changes? So if you are moving from north to south and we take a right turn, so how would our row and column change? So if you're moving in this direction, let's say, and we take a right, how is our row and column changing? We remain in the same row, we change the column, right? So column will decrease by -1, right? Column -1. Else if the direction is equals to 2, we start moving in the direction 3. See, if we are moving from east to west, we start moving towards south to north. That is direction 3. Right. And how does our this value change? So if you are moving in this direction, east to west, so that is this direction. We are moving in this direction. We see a 1, we start moving towards south to north. So we change the row by -1. Else, if the direction is equals to 3, which is going to be the case. Now here the logic would be there. How will you update direction if the direction is 3? So you're moving from south to north, you start moving from west to east. Now the direction changes to 0. Okay, done. See, so you were moving from south to north, you start moving from direction west to east. Which value represents direction west to east? 0. So now you reach that cycle. So your direction is either going to be 0, 1, 2, or 3. It is never going to be 4, 5, or any other value, because we have never updated it to those values, right? We are updating direction in such a way that it will always result in 0, 1, 2, 3. Okay. So now let's now we are moving from south to north, and we take a right turn. We see a 1, we take a right turn. So we we stay in the same row, but our column changes and column increases by 1. That's it. Done. So this is the entire logic. Just simple if else conditions that you had to write, and this was the only concept how you can maintain the direction. You can use a variable to maintain it, you can use a character to maintain it, you can use a string to maintain it, right? So however way you want, right? However way you want to maintain this, you can maintain. Okay, once you come out of the loop, your row and column will be this index will be not valid. You'll terminate this while loop. Okay, now the final question, how do we print that last index? So see, when you come out of this matrix, first tell me, understood this concept, everything till here? How are we updating direction? How are we changing the row and column? All the concepts, everything clear? Any doubts? Looks clean, looks easy. Okay. So now the last concept, what will we do? How will we print this? See, so your row and column, we can print the row and column, but the problem is row and column will be, one of them will be out of bounds, right? So for example, that's how this loop has ended, right? This loop will only end either the row becomes -1, row becomes equals to n, column becomes -1, column becomes equals to m. So you can check using that, right? Whichever exhausted and how it has exhausted, you can do that handling. Okay. I generally avoid those kind of handling because I don't like them. So let's say, let's call it as last row, last visited row, and which is equals to -1, last visited column, which is also equals to -1. Okay, what we need to do is we need to just store this last row every time we are updating it, last column every time before updating it. So before we have done this update, now we have we just stored these two values, done. Okay, so before update we store the value. Now let's say even if the loop updates and this value becomes some out of bounds, we end this. So these two values are going to store the last known last row and the last column. Understood? So these two values will store it. Now, like let's say this condition somewhere it got updated, it became out of bounds. Next loop condition does not satisfy, went it over here, but these two values will be storing the last known values. Okay, we have to return an array. Okay, so then that's also fine. So okay, so you, instead of these two values, you can create an array as well that would store this. So let's create an array. So it is a 2-dimensional array. Okay, what is the size going to be? It's going to be a single row, 2 columns, right? First row, single row, 2 columns. So you can use a of row 0.
Sir, 1D array, sir.
It's a 2D array. Achha, here. Oh, that is input. Sorry, 1D array. ठीक है, it's 2. Oh, ठीक है. 0, a of 0 is equals to the row index, so you can store the row. A of 1 is equals to the column index, so you can store the column. And just return that instead of printing this. Also, we have taken it as a. These are the mistakes I always make in interviews as well. I just keep on taking random variables name, then there is conflict. And then I keep on resolving this. I don't know when this thing will get resolved for me, but yeah. Yeah, but if your logic is correct, now the interviewer rarely sees these small things because he knows that that will be corrected. That can be improved. That can be corrected. Right.
Hello, sir.
Yes.
Sir, please explain the first line of the else part, sir.
Okay. Okay, submitted. So see this, for example, here it will, even if we don't write this, it is not going to be any problem. If we submit it, it's going to get submitted. Okay, even if you don't write that line, okay, a of ij equals to 0, you will end up like with the correct solution. Why we have written this? See, it has been told in the question what it is telling. See, if you like, if let's say you keep on taking right turns, okay, let's say you are moving in a street. Let's say this is the view, right? I don't know, this shows in cartoons, but I don't know where it exists in reality. The houses are there and these are the roads. If you're moving in this direction, you took a right turn, you came to here, then you again took a right turn, you came to here, then you again took a right turn. So now this is a loop, right? See, if you keep on taking right turns, you might end up in a loop, right? Now how will you avoid this loop? So it has told that, so when you are so it is telling that when you are taking this right turn, so just keep on marking these ones to zeros, right? Every time you're taking these right turns, keep on marking these ones to zeros. So next time you, let's say, you reach over this index, so you will not be taking a right turn, you'll end up passing straight in that direction. You'll not take the right turn then. Okay, so that's what it has told simply. Okay, understood? So if you anyhow reach this reach this position again, you will not end up taking moving the same direction. You start moving in that straight direction, so that you don't end up in a cycle. Otherwise, if you again take a right turn from here, again take a right turn from the right, so you might end up in a cycle. 0 0 is in a position 1, then also it won't vary, right? That's what I showed you, right? Even if 0 0 is in a position 1, so what would happen is, let's say, so this is the position, let's say. Okay, so here it was 1, so we took a right turn, we kept on moving this direction. Now again we saw 1, so we are moving from north to south, we take a right turn, we simply come out of the matrix. Okay, so this is what is going to happen, and this is the cell that is going to be our output. Understood? We'll always end up going -1, right? We'll always end up with not always end up going -1. We might go straight as well. So for example, let's say this is the scenario 0 0 0. We might end up with this direction. We'll end up with row equals to n, right? So we might not always end up with this. Row might be n, column index might be n. Actually, if all is 1, if all of them is 1, then what would happen is we take the right turn in the first value, we take the right turn in the second value, and we come out of the second value itself, right? Yeah. Okay. Understood, everyone? Now it looks easy, clean. So the code is easy. It's just that nested if else checks, right? You just need, if else, nested if else. There is no complicated thing that's over here. Only thing that was, I'll say, it's a little bit tricky for you to first figure out was this direction. Yes. Thank you for reminding me that. Okay, now since most of you are over here, let me take just 2 minutes. I'll take 3 minutes to discuss this. See, so yesterday I was discussing with the other instructors, like what are the difficulties that the students going from module 1, module 2, what they face later in the modules 3, right? What are the challenges that they are facing in the interview, right? Or what are the things or that we can cover up in the initial modules that will help you going forward. So one thing was memory, right? Memory concept needs to be strong, so that helps you understand any data structure going forward, right? So for example, if you know about memory, right? Since now whenever I covered about things like arrays, I talked about array list, right? So whenever I talked about a variable, I told you how it is stored, right? What is stack, what is heap, what is string pool. We'll today also string concept will again see string pool, what it does, right? Why do we have a separate space for string and all those things? Okay, so that is one thing that helps, right, for the students, right? One feedback was there. The students who like don't understand memory concepts specifically, they face more difficulty in the data structure understanding. What is stack, what is queue, what is linked list, how can you implement a stack or queue using array, right? How can you implement a stack and queue using linked list? So all those concepts you become little bit more difficult if you don't understand memory. So that was one feedback that I got. So that I wanted to point out, right? If you have doubts related to memory, right? So whenever we are discussing concepts related to memory, I know it's complete theory, right? You don't need to write code in that way. You don't see that yourself. So, but you need to know, right? If you have doubts, ask me that. Okay, I will be very happy to clarify that, because that will help you later as well. So all the advanced, and like as the data structure becomes more advanced, like trees or graphs or heaps, you need to know more about memory, because that is complete memory implication. Okay, so that was one thing that came out from that discussion, that memory concepts needs to be strong to understand that. And the students who have strong memory concepts, who understand them in the first module, second module, and they like do it, they rarely face doubts, or they are easily able to grasp the concept. The students who don't understand it, who like kind of neglect it initially, are the ones who face more doubts. So we have to cover it again, so that that is little bit wrong. So whatever I have covered till now, that's enough. That's more than enough, I'll say. Okay, so whatever we have covered till now, that is more than enough. Whatever else is required, I'll cover in the first module itself. Okay, so that is there. See, here I have also covered it like again with the previous batches as well, and other instructors have also covered it. But what happens is, the problem here, what happens is, since this is something which you're not writing every day, we know array, we know array list, we know 2D arrays, you're writing that in form of code every day. So you are concepts, right? But memory concept is something which I told in a class. You saw that, okay, you understood that aisa kuch to hota hai, and then later you forgot, right? But like you don't have to do that, right? You don't have to forget them. You have to, like, very small concept, right? If you feel like you have to make a 1-page note that you can stick to your wall or something, that will help you recap students to it, right? So if you find that way comfortable, create a 1-page note, right, that you can paste in your wall and you can look at that every day, have one glance of it, right? So that will help you remember it. बहुत छोटा सा concept, it is not very any advanced concept that is not easily rememberable, right? So that was one thing. Second thing was, what are the other problems that students are facing? So this I don't know, like how to state it. See, so so for example, let's take the current batch, right? So I have like around 60 students right now in the class, right? So out of those 60 students, I see like say 20-25 students are interacting continuously. So I know that 20-25 students are asking doubts. If you have doubts, you ask it. There are 20, like I know 20-25 students are genuinely focused, right? I know there are students who don't want to interact in chat too much, but they are listening very carefully, right? So if I ask something, they try to start thinking what sir is asking, right? What I'm asking, what we are doing, right? So they are very focused way, they are listening. And then there might be few students who are not interacting and you're not like listening focusfully, right? So now that is like something problem. If there is like you want 3 hours is getting too long, you're not able to do very focused 3 hours, so you can rewatch that recording, right? But don't skip concepts that we are learning, because that is going to become a very big problem going forward, because the things are going to get difficult, right? See, I know we have like you are going to get a job, your goal is to get a job. We are there to guide you in any possible way, right? So we will do that, right? We have everything in place to guide you in the most in the best way possible to get you the dream job that you are expecting, that you are wanting. But for right now, I want all of your goals should be for the first 3 months, right? Forget about job, your goal should be learning concept, right? If your concepts are strong, if your skills are strong, right, no matter whatever is going on, right, anywhere, if you are the let's say if out of 100 candidates you are sitting, you should be that well prepared that whatever question is asked to you, you are answering it, right? No matter whatever the other candidate is showing, whether he is answering, whether he's not answering. So you should prepare yourself in that, right? So your goal should be scaling up or learning something, not just clearing a module, right? See, module clear karne se is not going to help you, right? You may clear the module with a very minimum knowledge. You can clear the module with a very vast amount of knowledge, right? So there is a very big difference that you will see when you will actually appear for interviews, right? कि limited knowledge के साथ module तो clear हो गया, ठीक है? You cleared the module with limited knowledge and you did it for all the modules. But when you will go in an interview, right? I cannot guarantee what the interviewer is going to ask. No one can guarantee what the interviewer is going to ask. Whatever he wishes, right? Whatever he feels like asking you, he will ask, right? He might ask you 2D array, he might ask you arrays. We can just give you idea that this company probably asked like little bit of DSA. This is more front end focused, so he might ask you more from front end, right? So that way we might be able to help you. But what the interviewer is actually going to ask, that's going to be completely different and might vary, right? So the most amount of knowledge you have, that will help you in that point of time, right? So your goal should be gaining that knowledge, not clearing the modules. So there was one problem that we observed is like, so there are students who are clearing the modules, right? Because the modules, like we have 50-60% criteria to clear out, right? So 50-60% you can score, you clear out the module. So take an example of a class, right? So for example, in the class there are students who score 90%, there are students who score 45%. Both of them get promoted to the next class, right? But in the actual interview, when the company is going to come, when the company is going to interview, right? Obviously, the person who has prepared well, right, who has scored more, he might perform better, right? I'm not telling that your score is just the source of truth, but your knowledge, right? You yourself should feel confident that I am learning, and your focus should be learning, right? You should right, mentally prepare yourself कि नहीं मुझे पढ़ना है, ठीक है? I am here to scale up. I will get a job. That's definitely I'm going to get a job, but I should get it after is improving my skills, or after gaining that knowledge that will help me in the job as well, in the interviews as well, right? If after the module there is, yes, after every modules there is module interview, there is module test, that's there, right? So that's there for like you to get that promoted to the next module. Those things are there, right? All the systems are there, but still what we observed is like the same thing, right? I told you there are students who are passing out like with good numbers, they are scoring good, they're having good marks, and they are having very good knowledge, and then there are students who are passing out and they have very limited knowledge. So I want all of you to not just stick to that limited knowledge. In like whenever we talk about real interview, no, there is nothing like कि ये syllabus है, there is no syllabus, ठीक है? Whatever interviewer asks, that is your syllabus, right? And it is, I will say from my interview experiences, it is guaranteed that there are concepts that will be asked in interview that you don't know, right? You have never heard of, you have never so you can say no for a few questions, right? So for example, if you get 10 questions, if you say no for 1 or 2 questions that you don't know, that's fine. But you can't say no to 5 questions or 7 questions, right? That will give you an idea that you have not like depth knowledge, you have learned it superficially, right? So okay, focus about DSA, focus on the theories that we are telling. If you require notes, if you want to create your own version of notes, if you want to stick to it, stick that notes to your walls so that you see it every day, and that just simply passes through your mind and you remember it the way, right? So keep asking questions to me if you feel sir ये memory concept समझ नहीं आया, right? I'm having doubts. Ask me, right? For those of you who are not interacting in chat, right? If you are listening, like, and that's completely fine. I'm not asking if you don't have doubts, just put yes, no. Don't do that, right? If you are listening carefully, that's fine. But don't do that if 3 hours is too long, 3.5 hours is too long. So you watch 1 hour, 1.5 hour focus where you are just marking the attendance. Don't do that, because that is going to harm you, right? That is going to later harm you. You might not see the harm right now, right? Abhi harm nahi dikhega, because right now you're not going to sit in that actual interview, right? You are not going to ask you that many questions. You might even clear the module, you might even clear the module test as well, right? But that is going to harm you later, because your knowledge will be not that depth. So if you want, you watch the recordings again. If you have doubts, use the doubt sessions. If you have doubts from me, use the revision sessions. I'm taking extra sessions we take on Saturdays, Sundays. If you have doubts, whenever I'm teaching or explaining something, put it out, right? Don't feel shy. If you feel shy, I'm not putting to everyone, do a direct message to me. I see all the chats, no matter whatever your doubts is. If your doubts is very easy doubts, if your doubt is very difficult, ask me that so that it gets clarified. Don't take that doubt with you forward. Okay. Do we get only one chance of clearing module interview? So see, an interview is never only yes or no. ठीक है, interview कभी yes and no नहीं होता है. Interview is like, so for example, interview is a measure of how much you know, right? How, whether we feel confident that you have learned enough. Okay, and sometimes even repeating modules is not. See, honestly speaking, how much time did it take me to learn DSA? Did it take only 3 months? Did it take only 4 months? No, I'd honestly say it took me 8 to 10 months or a year around to learn these concepts, to learn all this DSA. The code that I'm writing is seeing that, okay, sir, this code looks a little bit cleaner. This looks a little bit crisp. We are easily able to understand it. So did it happen in 3 months? No, it took year for me to write. Then I practiced it for again months. So 1.5 years. Now we are expecting, I know our expectation a little bit more from you all, that we are guiding you, we are supporting you. But if you require कि sir ये तो recursion बहुत hard हो गया, linked list is very hard, let me do this module once more so that I'll gain that knowledge. That also we are giving you, right? If you want, you can like by choice also you can repeat that module. It's not always by compulsion that you have to repeat. And students do repeat them by choice, that I want to learn that, right? So that is also fine. Okay, but don't be on that bracket that you are learning it superficially. You are just trying the coding. You don't feel interested in that theory concepts, because DSA is fine. You will have a very good DSA knowledge. That I am telling. If you solve 500 questions, you are going to have a very good DSA knowledge. But your goal should be to learn that problem solving skill, to learn all the theory concepts that's behind it, all that memory, all that data structure concepts, all the additional, like in conditional also I told you so many cases, right? So even someone is very good at programming, just go and put a dangling else case in front of him, or just put a switch case of what would happen if these values are not constant, will it work or not, fall through scenarios, right? All those cases put in front of him, he might fail, right? He might get issues in something, even though he's doing DSA very fine. He's like, he has solved questions till graphs, right? So these are the things which will come in interviews, and you should be prepared from them, right? So if you feel like taking notes, if you feel like writing it, creating notes in your own version, going through my notes, I've mentioned every examples or everything that I've covered in the class, everything is there. So do that, but do ask doubts, right? Don't take them forward, and don't keep your target as clearing the module. Your target should be gaining knowledge, right? If that is your target, you will definitely do better in the modules ahead, or even in the interviews. Okay, so that was the one discussion that we thought, and we thought ki let's directly tell the students to focus on these things. Okay, because these things you will not notice now. And there was one special case, and I am very much confident none of you are doing. If anyone is doing, please don't do it. Okay, so there was 1-2 scenarios which happened in the previous module. So what was happening is, there were few students who were copy pasting the solutions from different places into the sheets. They were like marking attendance of the classes. So their scores in this was good. They like their scores in assignments were good. They had like even copy pasted the solutions from the module for the module test, so that was also good. And then somehow have cleared the first and second module interviews, right? Now they are very now they are very much in problem when they're in module 3, because now they see that in the interview there is no copy paste, right? How will they copy paste, right? How will you cheat in an actual interview, right? There is no, how you cannot do anything in an interview, right? So now they have started learning the concept that they left behind in the module 1, where they copy pasted, or where they like somehow bypass the entire checks that we are doing, right? So now they are revisiting the module 1, and they are learning that, because that itself is not clear, and they somehow cleared it, that they thought ki if we clear all the modules, we'll get to the interview, and interview will clear it, right? Interview bhi clear ho jayega. And in actually it doesn't work that way, right? Interview to ऐसे clear नहीं होगा. Interview is going to ask questions, right? So I am expecting none of you are doing that, right? So that was like the scariest thing, like We saw that was like not from a lot of students, that was 1 or 2 students. Might be their friends might have helped them, right? Might be the other students who are there, so they have helped them. So if someone is like asking you help, you are discussing within yourself, that's fine. I encourage discuss within yourself, but try to understand the solution, try to write it yourself. Whenever I write code, I also encourage you to write that code yourself, right? Not simply copy paste my code and submit the solution. That is not going to help you. If you write that code yourself, you see the errors, you, even though you know that there is a solution that's there to me available, I have shared it, but try to write it yourself, fail, try again, see, resolve the errors, resolve the issues, see the difficulties yourself, and then you will be able to understand it, and then you will be able to solve it yourself. Okay, so do this. Okay, I'm expecting you're not doing at least that cheating and all those things, so that I'm like I'm expecting you're not doing that things. But apart from that, all the theory things, all the things that we are learning on the top of your DSA questions, okay, do that. Okay, and this time I've seen good participation of you all from Zim. Okay, so that is also one thing. So we so assignments are fine. If you are doing assignment, that's fine. Assignment is the minimal thing that you should be doing. The more Gym questions you solve on the top of assignment, so assignment you have to complete, right? That is like the most curated questions that you have to anyway solve, right? If you're solving them, it's fine, but you should also spend time on Gym, right? So assignment, let's say, has altogether on 3 modules 300 questions, 400 questions. Okay, out 400 500 questions, let's say it has 400 questions, so those are easy, medium, and you might also see later hard questions as well. You should also start solving easy, medium, hard questions from the Gym as well, right? If you feel the harder right now too difficult, solve the easy, medium ones at least, right? If assignment is taking time, okay, so for example 2D arrays, we have like covered all the different kinds of questions that you might get, right? So all the different variations, at least one question of each kind of variations is there in the assignment. Apart from this, if there is other questions, right, other variations which is not there in assignment, so that you'll get from Zim. Okay, so do that. I guess variations here, you might see even like few variations on the top of these concepts that you have done, right? So what are the other variations of question that you'll see? If it's taking time, that's fine, right? Keep on doing it, use the weekends to do it, right? Keep on practicing more and more. Logic building is very frustrating, right? I know that you have to think, and it will not strike, right? It will not strike. You have to think, you might need hints, you might be seeing solutions online. That's fine. Okay, spend time. Gradually it will develop over time. See, it's like riding a bicycle, right? So on the day 1 you fall, on the day 2 you again fall, on the day 3 you break your knee, on the day 4 you are severely injured, right? But if you give up, right, you will never learn to ride the bicycle, right? So I am there to hold your, right, hold you to make that bicycle stable, so that you start paddling it up, and some point you will feel that you don't need that stepneys, right? You have 2 stepneys, you have doubt sessions, you have live sessions, you have everything, and some point you will feel you don't need any one of the stepneys, right? You can yourself think, and if even if you try to Google up, you get some solution, you'll do it, right? So similar to how difficult the learning riding bicycle is, or learning riding a bike is, or learning a car is, that difficult learning programming is, right? So, and I never told that it's easy. It requires patience, but you can do it, right? You all can do it. It is not, no rocket science is over here. Very easy concept, very easy. Just that it requires practice and practice and practice to develop it. Okay, riding bicycle everyone does, right? Everyone knows how to ride bicycle. Even like students, like small kids do it. But to like, so remember the days when you were riding the bicycle, right? You fell, right? You fell every day, you were falling, right? You're falling again and again and again. But did you give up? No, you never gave up, because you wanted to ride that bicycle, right? You were so like, you were so engaged into it. You might have broken your knee. I remember I fell so many times. I had scratches on my hands, I had scratches on my knees, but I used to go and ride. I don't know if today I tell you the same thing. Since we have grown ups, we don't have that much amount of like patience and zeal to do things, right? So just that you have to remember those days, and you have to keep on doing it patiently, right? Okay, how many of you learned riding bicycle without falling? Okay, that's fine, right? Never fell from bicycle, anyone? कोई भी नहीं रहा, everyone learned it. ठीक है, we'll discuss a lot of interview questions, right? So that will do. Crash the wall once learning, right? Everyone fall, right? Everyone fell from bicycle, right? So that's the same thing. Right now you're falling, you're frustrated that I can't do it, At one point of time, after doing it for 2 months, 3 months, you'll realize, okay, now I'm not falling anymore. Now if I fall, I put my legs, right? If I fall, then I have my like I don't even need both of the stepneys, I need one stepney, right? If I don't have both the stepneys at all, then also I can ride it, right? So you'll be in that mode, right? So right now you're starting, you'll fall, it's expected. Everyone fell. Okay, I gave up programming 3 times because of not able to do DSA. Okay, I thought कि चलो front end Android कुछ तो सीख लेंगे, I'll get some job not doing DSA. But later I realized कि this is the logic, right? You have to do it, and once you start doing it, you'll learn it, you'll enjoy it, right? हाँ. I'm like Sandeep Maheshwari. ठीक है, चलो, if that helps, then I'm okay with it. Coding. So I'll say my job itself is frustrating, right? So if any developer says, "Nice job is not frustrating," any FANG engineer, so that is life is on YouTube. What you see, right? We are enjoying it. There is food, there is fun, there is tennis, there is like everything in office you enjoy. And no one shows what happens behind the scene, right? Everyone shows that 15 or half an hour of enjoyment that like everyone does in their engineering life every day, right? But what about the remaining 7.5 hours, 8 hours of work? What they do? Sit in front of a screen, try to think of solution, try to figure out that one bug, why it is coming, try to optimize the code that is very difficult to optimize, or try to find out try to do some engineering solution that is very difficult to. Okay, so that no one is showing. Okay. So right now you're learning that, so that part is difficult. The easy part is like everyone showcases that this is the easy part. The difficult part is here, right? So let's discuss this question. Okay, so this was the thing that I wanted to discuss. Okay, so if you have doubts, come to me. You have the other forums as well. Now, like I would say, whatever concepts I'm teaching, right? If you, whatever way you feel you can remember them, do it. Okay, write notes, stick it to your wall, paste it. If any one of you who is like very good at making notes, showcase your notes in your WhatsApp groups, right? So today, whoever like creates a very good notes and paste it into your wall, put that photo in your WhatsApp groups and show to all of your other friends, right? How you did it, and let others also create their own copy of it. And I know like a few of your engineers, they will just use that photo of that notes and they will learn it. So that is also fine. Okay, just do it. Okay, if you want that. If you are able to remember this concept, that's very fine. Okay, so I don't look at notes and explain it because I now remember it, how it is happening. But yeah, you will reach that point where you will remember all these things by heart. Okay, you don't need to write notes, but okay, for now, if you need, you can write it. Okay, so let's see this question, maximum minimum, then I'll give you a quick break. So this is a very easy question actually. Okay, so what this question is telling, that you are given an n cross n matrix, right? So this is square matrix. This is not a row, column, or anything. This is a square matrix that either you'll have 1 cross 1, 2 cross 2, 3 cross 3, something like that. Okay. Now what you have to do in this matrix, you have to find a value. Okay. Now what is this value? What's the unique property of this value? This value is smallest in its row and the largest in its column. Okay. If there is no such value that exists, then we have to return -1. Okay, so for every value in the matrix, what I have to check, that this should be smallest in the row, this should be the largest in the column. If it is, then we are good. If it is not, then we'll check for another value. Okay, understood? So for example, take the first input as example. So here is 1 smallest in the row? Yes. Is 1 largest in the column? No. So 1 is not the solution. Is 3 smallest in the row? No. So 3 cannot be the solution. Is 6 smallest in the row? No. Is 6 largest in the column? Yes. So it cannot be also the solution. 5, is it smallest in the row? Yes, it is smallest. Is it largest in the column? Yes, it is largest in the column. So 5 is our solution. So it should be smallest in row and largest in column. So, or in general, if I say, if let's say a value is ij, okay, a matrix value is a of ij. So this is the matrix. Okay. Now, in this matrix, we have like two values that two indices that we know, ij. What does these two index also tell us? right? So these two index are very useful. This tells a lot of things about the position of that value in the matrix. So for example, I tells us the row index of this matrix. So it tells me the row index. Okay. What does J tells us? J tells us the column index of this matrix. Yes. So I tells us the row index, J tells us the column index. So for example, if for any A of ij, for any value, let's say A of 3, A of this 0, 1, take a 0th row first column. A of 0, 1, what is this value? This value is 3. Okay. Now this, which row does it belong? It belongs to the 0th row. So this belongs to the 0th row. Which column does it belong? This belongs to the column value 1. So this belongs to the first column. So this row index is 0, column index is 1. Can we use this information somehow? Yes, we can use it. So using this 0th row, we can check whether it is smallest in the 0th row. Using this first column, we can check whether it is largest in the first column. If yes, if both of these conditions satisfy, then we found out our solution. We have to just return that. Okay. That's it. Okay, understood the question? So for any matrix value ij, you are given two values. I is the row index, j is the column index. Now you have to check whether it is the smallest in the row, right, in the 0th row, in ith row, and it is largest in the column, that is the jth column or like first column, whatever column index it is. Okay. So let's write first a solution and then we'll think if we can optimize it or do anything with it. So firstly, let's get a solution. Okay. So and till what values we have to do it? We have to do it for the entire matrix. So let's take it as a dot length and m is equals to a dot a of 0 dot length. It is, I know it is given a square matrix, but I prefer writing it in this way. So it is a square matrix. So if you write n cross n, that is also fine. Okay. So for the question, it has told that it is square. Okay. Now what we have to do for each of these a of ij, for each cell, so we can find the largest in the column first and then check if the largest is smallest in the row. I'll talk about optimization and its problems. Okay, let's first write one solution and then we'll check also the complexity wise, right? So it is order like n cube, sorry, 10 to the power 3. Now let's say what's the complexity we are getting and whether it will work or not. Okay, so what we have to do over here is for every a of ij, the current value is a of ij. This is the current value. What we have to check that this value should be smallest in the ith row and largest in the jth column. How do we check it? So let's say we take a flag and we mark it as, let's take a boolean flag. Okay, let's call it as flag, which is true. What does flag true means? That this is, I'm assuming this value is smallest in the ith row and largest in the jth column. Okay, smallest in the ith row and largest in the jth column. How will we ensure that this is smallest in the ith row? So we'll check through the ith row. So we'll start with k equals to 0. K is less than n. K plus, sorry. If I have to traverse the ith row, so we'll go through all the columns in the ith row. So what I have to do, my row index is fixed, which is I. So I have to check if a of I is larger than any other element in the ith row. If it is, so current value is a of ij. Is it greater than any other value in the ith row? So our row index is fixed. I'm changing columns from 0 to m. So I fixed the row index, that is I, and I'm changing the columns from 0 to m, which is this. So I'm checking, is this value greater than any other value in the ith row? If yes, then we can mark this flag as false. Why? Because then this is not the smallest value in the row, because this is greater than at least one value in the row, and this is not the smallest definitely, and we can break. Okay, understood this, what we have done? So initially we assume that the flag is true, which means this value is smallest in the row. Okay, smallest in the row, largest in the column. Now we started to check whether this is actually smallest in the row. Now how did we check whether it is actually smallest in the row? So our row index is fixed, which is I. A of I is the row index that is fixed. Now what is the column index? So the column index would vary from 0 to m. Right, so column index is varying from 0 to m. So I have to go through each column, right? So in the ith row, in the let's say 0th row, I'll go through each column. Okay, in the 0th row, I'll go through the column 0, column 1, column 2, and so on. and I will check whether the current value is greater than any one of the values. If it is, then it is not the smallest value in the row. Right? If it is greater than any value in the row, then it is not the smallest value in the row. We can mark the flag as false. We can come out of the row. Okay, understood? Clear now? We can just mention MNN in function definition, but if it's not given, then it's best is to take like calculate it within, not to modify the definition. Okay. Okay. I'm not seeing any doubts, so I'm assuming it's clear. Again, we'll do the same thing, but this time we'll check for the column. So how do we traverse a column? We change the row index value. So row will change from 0 to n. We'll increase the, okay, sorry, here I will take k plus plus, sorry. Yeah. We'll increase the k. And inside this, we'll validate if a of ij, if this is less than the current value is less than any other column value. So our row index is changing by k and the column value is fixed by j. See, see here what the condition is varying, how it is varying. So first time I checked that the current value, is it greater than any other value in the current row? So I fixed I and the column index is changing. Okay. Now here I'm checking if the current value is less than any value in the column. So if this value is less than any value in the column, that means this is not the largest value in column. So I have to check for, this is checking for largest in column, whether it is largest in column, and this is checking for smallest in row. When this is not the smallest in row, if there is any value which is greater than this, sorry, if there is any value smaller than this, then this is not the smallest in row. When it is not the largest in column, if there is any value that is larger than this, then this is not the largest in the column. Okay, that's it. If this is there, then we mark the flag as false. We break the loop. Okay. Now at the end, finally, if the flag is true, if the flag is still true, that means we got our result. If the flag is false, then we don't have any result on this. We'll check for the next iteration. Take a next iteration, we'll check the next iteration, we'll keep on checking, we'll check for the entire matrix. Now, and at the end of checking for the entire matrix, we'll be able to know whether there was any values that we found out or there was no value. Now, if we found out no value, then the question is told we can return -1. If no such values exist, then we can return -1. Okay, understood? So for every
line number,
yeah,
line number 10 bata de.
10 kuch nahi tha, that was just I've written like to show. So yeah, so that was like just to show you which is this.
Okay.
Okay, see, so what I'm doing, see, this is like the normal matrix traversal, right? These two loops will simply traverse the matrix. Now, once you are within this J loop, you will get A of ij, right? A of ij, which is your current value. Okay, so forget about this internal logic that I've written over here. Isko bhul jao ek second ke liye. Okay, so what we have done over here, when these two loops are there, we get A of ij. What is A of ij? A of ij is your current matrix value. So we are traversing through the matrix, we are traversing, going through this row, second row, third row, fourth row, so on. So we're going to each value in the matrix. Right now, each of these values is nothing but A of ij inside this loop. Now, what we have to check for each A of ij? For each A of ij, I have to check whether this is two things. This should be smallest in row and this should be largest in column. If this satisfies both the conditions, then this is my solution. This is the result that I was looking for. If this doesn't satisfy both of the conditions, then I'll look for another A of ij. Okay, so first I'll look for A of 0, 0, whether it satisfies, then I'll look for A of 0, 1. Okay, so first I'm looking for 0, 0, then I'm looking for 0, 1, 0, 2, then I'm looking for 1, 0, 1, 1, 1, 2. So I'm looking for all the values, which value satisfies these both conditions. The value that satisfies both of these conditions, that is our solution. If none of the values satisfies both of these conditions, then I will return -1 at the end. Okay, now okay, now okay, so here how am I checking? I took the initially assumed flag is true, which means that I assume that this satisfies both the conditions. Now we'll validate whether this assumption is correct. So we checked if it is smallest in the row. How did we check? If this is, I'm claiming this is smallest in the row, then there should not be any other value smaller than this. So this should not be greater than any other value in the row. If it is greater than any other value in the ith row, right? I have kept the ith row and my column index, this is a of ij, and I'm varying the column index k. So if this is this particular row, there is any other value which is smaller than this, then this is not the smallest. So I'm marking flag as false and we are breaking this loop, right? Otherwise, okay, otherwise I will check whether it is largest in the column. Like, how do we check whether it is largest in the column? So we simply do this. So we go through this entire loop again, and right now we are going through the rows, right? So I've fixed the column index now, which is j, which I have fixed the column index, and I'm varying the row index. Okay, so this row index is fixed and here it is varying. So I'm checking whether there is any value in the current column which is greater than this. If there is any other value which is greater than this current value, then this is not the largest. I mark the flag as false and I break. Now, finally, if the flag is true, that means this condition never satisfied and the above loop condition also never satisfied. So there was no value smaller than this. There was no value larger than this in the column. Okay. So that means this was the value I was looking for. So I return the result. Otherwise, I return a -1. Okay. Achha. Understood? Let me show you the logic. Let's test it. Okay, I'll talk about the complexity. This is not the optimized code. It can be optimized. Okay. First, let's check the complexity. Okay. We got 5. Okay, which is
please run the second example, sir.
Okay. Achha, here there is a problem. Okay. So in this second example, the size is not given. See, so in the first example, the size was given, which was 2. Here the size is missing. So here this input is incorrect actually. So we have to write it 3. So this tells that this is a 3x3 matrix. Okay. So that is missing in this input case. Okay, there is a typing mistake over here. Okay. Okay. Okay, now if you submit, it should be fine. Okay, now let's talk about optimization, right? Since we know this, now this fine. Now, and this is not the optimal solution, right? If you compare with the time as well. So see, what's the constant that's given? N is 10 to the power 3. What's the complexity that we are getting? So let's look. So firstly, we have this is order n, this is order n. What's the inner loop? So what this complexity is? So this is order n plus order n, right? So this is order n plus order n, which is big O of n. So finally, it becomes big O of n cube. Right? So outer loop is n, and this is 2n. So 2n, outer loop is into n. So this is 2n cube, or we can say big O of n cube. This is not fine, right? Big O of n cube is not fine for 10 to the power 3. If the matrix was n to the power 2, then we were fine, but it is 10 to the power 3. So this is not the optimized code. Now we need to think what else we can do so we can optimize this logic. Okay, let's check. So I always told you, right? The thing that you need to optimize is the innermost loop, right? Innermost loop would be taking time. So these two loops which we are doing over here is taking time. So like the test cases are not having constants, right? So in the module 1, there are like questions which don't have stricter constants. From later going modules, you'll see stricter constants. So, and you'll see test case failing because of time limit exceed. For module 1, right, we have not given that many stricter constants. Okay, so that's why it's passing. There are only very few questions which is having strict constants. Now, so think what else we can do. So we need to find out smallest in row. We need to find out largest in column. Think on this one. We can check column condition only.
Sir, here when we found the smallest index row, let's assume that we find the smallest index in row 1. Can we again find the smallest index on largest index is only column 1 or every column?
So this is like for right now, what we are doing is we are checking for the current column, right? So we are checking for the current row, we are checking for the current column. Okay. So here, see, okay, hello. So what I told you, keep this checks are taking time, right? If we can somehow figure it out, if we can do these checks instead of order n to order 1, then our logic is correct, right? Then we would get n square, which is fine. Now, how can we reduce this check from order n to order 1? That can only happen if we already know what is the smallest value in the row 0, row 1, or row 2, right? If this current value is equal to that, then this is the smallest value. So for that, we need to know what is the smallest value for any row. Similarly, we need to know what is the largest value for any column. Okay, and this is a good example of how you can trade time with space. Okay, so here if we use additional space, which can tell me what is the smallest value for each row and what is the largest value for each column, okay, that will basically solve this problem. Okay, so let me explain that what I'm telling. So what I'm telling here, so let me first paste this logic somewhere so that you all don't lose this code. So let me paste it over here. I've not written the previous code in this. I'll copy that as well. Find a way, I'm not pasted, right? So I'll paste this one. Find a way, did I close it? Find a way is here. Okay. Okay. So let's see. So what we need to do is see. So we need to do both these operations in one time. How can we do it? Yeah, date. Yes, date was missing. So today's date is 21st of March 2023. Okay. Okay. Now let's look at this. So here we need to do both these checks in one time. How can we do if we already know that
Sir,
value?
hello.
Yes. Yes.
Sir, my problem is not about the time complexity. My problem was the code I want to tell you, sir. Sir,
Okay.
yeah, in the smallest in the row, let as let as of the example 2, sir. From the current index of 1 is the first value. Then we check the first row and we see the one is the smallest.
Yes. So we'll check if there is any other value which is smaller than this. There is no value, right? 1 greater than 2, 1 greater than 3 will be false. So we never hit this if condition. So this is so this value flag will still be true because there is no value smaller than this, right?
Then one is the small one.
Yeah.
One is the smallest value.
Now we go to for the same thing. We'll check in the column as well. Now once we check in the column, so we will check this condition is 1 less than
here we only checking the first column, no, sir?
First column, yes, yes. Only first column.
Not every column.
Not every column, right? It has to be just smallest in its row and largest in its column, not the entire.
No, sir, the question is not saying that, because the question is saying that explain. So sir, the second second way explain देखिए.
Okay, see what the question is telling, it has to be smallest in the row and the largest in the column. Okay, it has to be smallest in its row and largest in its column. So for example, here see. So in case of 1, what are the values with which I am comparing? 1, 2, and 3 in the row. So it is smallest in its row. What are the values in the column with which I am comparing it? 4 and 7. So is it largest in its column? No. So no. 1 is not 1 is smaller than 4, 1 is smaller than 7. So it is not largest in the column. Okay. So 1 is not the solution. What's the solution this is giving? This is telling that 7 should be the solution, which is fine because 7 is it smallest in its row? Yes, in its row 7 is smallest. Okay, in this particular row. In this particular column is 7 is largest. Yes, in this particular column 7 is the largest value. So that's why 7 is the answer. Okay, got it?
Okay, sir. Okay, got it, sir.
Okay. So now let's figure out this solution, how we can check this. Okay, I'll take 10 minutes extra, then I'll give you dinner break. I know it's getting late, but take a beer with me. Okay, so let's take a let's take a row. Let's take a like array which will just store the smallest in the rows. Okay, let's make it as smallest row values. Okay, how many rows we have? So we have n rows. So let's create this matrix of n size. Okay. Similarly, let's create another matrix which will show the largest in the column. Okay. what will this store? The largest value for each column. Okay, and this will be of m size. Sorry, number of rows are n, number of columns are m, so this will be of m size. Okay. Now see, now let's try to figure out the how we are going to update the first row. So let's say we want to go through each of the rows. So what we want to do is we want to iterate through each of the rows, and we want to find out what is the smallest value in this row. So for row 0, what is the smallest value? So for row 0, how can we find out the smallest value? We need to traverse the entire row and we need to find out the minimum. Do we know how we can find out a minimum in the row? Yes, we already know. If we are given a one-dimensional matrix, we can find out the minimum in that, right? This we already know. Okay, we just need to store it. Okay, so this now looks easy. Okay, let me write the code. It will be it look even easier. So let's take integer dot max value, right? And we can go through the entire column, that is j equals to 0, j is less than m, but okay, like if it is in the first row, then it's fine. But we don't know, right? So we'll check for each row. So we'll try to see now. Check if this minimum is greater than any particular array of ij. So in the first row, is there any value? So we'll update the minimum. Okay, so minimum will change it to a of ij. So now what this would do, this would give me the minimum in the ith row. See, after this loop is done, what will we get? We'll get the minimum in the ith row. So for when I is equals to 0, I'll get the minimum in the 0th row. When I is equals to 1, I'll get the minimum in the first row. When I is equals to 2, I'll get the minimum in the second row. Yes, yes, understood this part? When I is 0, I'm trying to find out the minimum in the 0th row. When I is 1, I'll try to find out the minimum in the first row. When I is 2, I'm trying to find out the minimum in the third row. Yes. So whatever I is, I'm trying to find out the minimum in that particular row. Now, once I get that minimum, what we need to do is we need to simply store it. Okay, let's say smallest row of I, and let's just store the minimum that we got. Okay, so smallest row of 0 will store the, so let's say this is the smallest in the row, which is smallest row, how it looks like. So for example, this current matrix 3 cross 3, this is the, how many rows this will have? This will have three values, right? This will store 3 values, 0, 1, 2. What does smallest row of 0 represent? So smallest row of 0 represents the smallest value in the 0th row, which is 1. What does smallest row of 1 represent? Smallest value in the first row, which is 4. What does smallest row of 2 represent? Smallest value in the second row, which is 7. Okay, so I get the smallest value in the first row is 1, smallest value in the second row is 4, smallest value in the third row is 7. Understood? Okay. Line 15. Oh, sorry, it will be minimum over here. Thank you. Okay. Now, similarly, can we do for the columns? Can we, so now we found out the minimums in the row. Can we do it same for the column? Okay, if we can iterate through the columns and find out the largest in each column. What is this? How much time is this logic taking? N square. Similarly, we can write a n square logic that will find out the largest in the column. So let's say we start with I equals to 0. Let me write it as row column. So you see the variation. Okay. So this index is basically I is row over here. Okay. Just check. If I tell you to just print return an array that is storing the minimums in each row, right? So how will you find out? This is the logic to find out the minimum in each row. So for I am fixing the row index and I am varying the column index by col. Okay, so I'm fixing the row index and I'm varying the column index, and after each iteration I find out the minimum in that particular row. Okay, here I'll need to do the reverse. I'll vary the I'll fix the column index. So column index will be 0. It will go till m column plus plus. Okay, so I'm fixing the column index and I would vary the row index. So I will go through each column and I'll find out what's the minimum value in each column. Okay, so okay. Now here we'll find out what's the largest value in each column. So how do we find out largest in a particular array or particular list? So we take the maximum as integer dot min value. Okay, and we'll check, is there any value if the maximum is less than, okay, a of row column, then we store maximum is equals to a of row column. Okay, at the end we'll write what is the variable to largest in the column is of with which column. So column is equals to max. Understood? So here we took integer dot min value. This is the entire logic to find out the largest number, right? We already know to find out the largest number, we take max is equals to integer dot min value. We check any other number, is it larger than this? Then we store that number, right? We just did it for each column. So first time this loop runs. So see, first time this loop runs, so we have fixed the column index. So column index is 0. Okay. Now look at here what we are finding out. So first time this loop runs, we are fixing the column index, which is 0. And we are varying the rows from 0 to n. So we are varying this. Okay. So among this, we'll find out the largest number. So what's the largest number we are going to get? We are going to get 7. So we are storing 7 in the LC of 0. So LC of 0 is going to store 7. Next iteration, we are going to run for this column and we are going to find out the largest in the column, which is 8. Next iteration, we are going to run for this column and we are going to find out largest in column, which is 9. Now we have two arrays. One array stores the smallest in the row, which is this. One array stores the largest in the column. Okay, now we have two arrays for each, like let's say smallest of 0 stores the smallest value in 0th row, smallest of 1 stores the smallest value in the first row, smallest of 2 stores the smallest value in the second row, largest of 1 stores the largest value in 1 row, largest of 2 stores the largest value of 2 row, and so on. Now do we need to do this check? No, actually don't. Now we don't need to do this check. So what you can do is, instead of doing this loop, I can simply check if the current a of ij, if this is equals to the smallest in the row, right? Which row? What is the row index over here? Which row I have to check it should be the smallest? What's the row index of a of ij? If a of ij is the value, what's the row index in there? Iska row index kya hai? It has two values, right? One is the row and the one is the column index. What is the row index of it? I, right? So I have to check it should be the smallest in the ith row. Say if the smallest value in the ith row is equal to this, then it's fine. If it is not equal to the smallest in the ith row, then it is not the smallest. So we can mark the flag as false. And same thing we can do over here. If this a of ij is not equals to largest in which column? Largest in the column J. If it is not equals to the largest in column J, then we can mark the flag as equals to false. Now see. Now this internal logic that we had written earlier in order 2n, now it is written in order 1. If this is not equal to the smallest in the row, or if this is not equal to the largest in the column, we mark flag as false. That's fine. If this is equal to the smallest in row and this is equal to the largest in column, then this is the value that I'm looking for. We'll return this. Let's check whether it is working fine for the inputs that we have. If I run for this input, okay, we still get 7. Okay, let's try to submit it.
Sir,
yes.
Instead of this, if we compare this two one-day array and get the common element, then the answer is also right.
That is also fine. So yes, that is also correct solution. So you can check if the smallest in the first. So actually that is actually there is one problem in there. There is one problem over here. So let's say, so right now, like for example, take for example this. Okay, so you are getting a 7 that is smallest in this row, right? And you're getting 7 is smallest in this column. Okay, so that will again be okay. That is also fine. You need to write n square logic. So for example, 1, you need to find whether there is any 1 in this particular value, whether there is 4 anywhere in this particular value, whether there is any 7 in this particular row. So that is again a n square logic, because this is how many columns you have.
Sir, here is also the n square logic, sir.
Here is also n square and this is also n square. Yes, so that is fine. So the complexity wise, both of them are n square. So that is a fine, and that is same logic, right?
Hello, sir. Am I audible?
Yes, yes,
Hello.
yes,
Sir, instead of this, what I just did it like find the largest in the row first, and I stored the like row value, and just check on the same like row. मतलब पहले मैंने सिर्फ कॉलम का निकाल लिया लार्जेस्ट, लाइक इसमें 7 आ गया, अब सिर्फ उसी जैसे थर्ड सेकंड इसकी रो आ गई, अब मैंने सिर्फ उसी को चेक कर लिया. दैट विल हेल्प अस टू like reduce too many like loops and stuff. There will only
ठीक है,
two
that is
loops.
fine, that is fine. ठीक है, ultimately complexity n square ही रहेगा. So for example, see here we are like, so anyhow you write, you'll get n square for this earthquake. Just a second, just a second, just a second. Hello everyone, you can take your dinner break. You can take your dinner break. I'm just coming back in 15 minutes. So there is a like earthquake that's going on. So I felt that there was like some tremor, but it's severe. Okay, so take your dinner break. We'll just meet in 15 minutes. We'll continue the discussion. Okay. Hello everyone. Welcome back. I hope you all had your dinner. I had to see some earthquake. So, no worries. Fine. Yeah, all good, all good. I'm very lazy, so I did not even climb down. So I was just here, just seeing if anything goes wrong, then I would think of going down. Otherwise, I was here. Yeah, no, I'm not everything. Actually, I live at 19th floor, so it's a very difficult choice to make, either to die down climbing 19 floors through stairs, or to die in the house. So I always choose the second one. So instead of climbing down 19 floors, that would obviously take my breath away. Yeah. Okay. So let's continue here. Okay, so now understood this. Basically, we have taken two arrays. One is storing the smallest in each rows. One is finding out the largest in each column. Now, since these two arrays are computed in order n square, so we have these two values. Now, for every cell, right? So for every a of ij, we don't need to recheck in the row or recheck in the entire column. We can simply use the value that we have stored. So we can simply check whether it is smallest in the row I, whether it is largest in the column j. If it is, then we have the solution, right? If it satisfies both the conditions. If it doesn't satisfy any one of the condition, that means it is not the solution. In that case, we have, like, if we'll check for the other values, if none of the values satisfy, return -1. Okay, simple, understood. I guess I was addressing some doubts over here. Okay, clear to everyone? Okay. I'm pasting this solution, go through it. Okay. So this is a classic example of how we can trade time with space. So what we did over here, so here we were taking some amount of effort, right? Now, instead of doing that effort, we figured out a logic where we have some space storing that result already, which we stores the already that result. Now we are using this space to store that result. We have some additional space like order n space that we have used. So this solution's time is order n square, but space is order n. Why space is order n? Because we have just two arrays of one size, that is 2n, which is order n space, right? So we have used order n space and we have decreased the time complexity by order n. Okay. So at times when you don't find solution,
Sir,
yeah.
don't understand the order in space, sir, because we use the 2D array. So why?
Okay. Apart from 2D array, right? 2D array is n square. Okay. So if you consider that input array size, that is n square. I'm talking about additional space, right? So additional space is order n. Considering that total space, it is n square because you need n square space to store 2D array. Okay.
So space complexity means total space or the additional place?
So it is total space. So like if you talk about space complexity, it is going to be n square. Because sorry if I confused you. So space complexity is n square, right? That is like if whenever we tell the space, we always talk about the total space complexity. Okay, I was talking about what's the additional space. So additional space we have used order n additional space. Okay. Apart from like what's required. So this we anyways require, right? To
Got
store.
it, sir.
Okay. 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 So this is it. So this is the solution to this one. Now I have one last question. Now thinking whether we should start string or we should do spiral matrix. Acha, since I'll tell you one thing. So since we did these two questions on this, now can you try the spiral one today? So, and I'll tell you, spiral one is very much similar to this. So this logic, what we did over here, we took a row and column and we were increasing or decreasing, right? Similarly, in spiral order, what you have to do is you have to increase the row, decrease the column. So for example, let's say this is our matrix, okay? And you start with the row is like 0 and column is 0. So row is 0 and your column is 0. So largest row value can be n and largest column value can be m. Okay. So this is like your matrix that you traverse. Okay. So let's say your row is 0, column is 0, largest value can be n, largest value of column is n. Now you do this boundary traversal based on this value. Okay. So you'll start with this value, do the boundary traversal. Once you're done with the boundary traversal of this, how your row and column is going to change. So row is going to increase by 1, column is going to increase by 1, this is going to decrease by 1, this is going to decrease by 1. Now what it changes? So it basically changes your matrix to this. Now, if you do a boundary traversal keeping these constants, you're going to get this boundary, which is the spiral traversal, which is the next spiral order. So if you connect this, this is the spiral order, right? So firstly, it's the boundary traversal of the matrix starting from row 0 to n and column 0 to m. and then it is the boundary traversal of the matrix 0 to n minus 1 and column 0 to m minus 1. Then again it is, sorry, row 1 to m minus 1, column 1 to m minus 1. Then again it is the boundary traversal of 2 to n minus 2, which is this 2 to n minus 2, and column is 2 to n minus 2. Understood? Now try this. There is only one case that you have to handle, which is what will you do in a case of single row, what you will do in a case of single column. That is it. Okay. This is only the edge case that you have to handle separately, like which you have to think. Otherwise, like this is going to break in case of this single row, single column. Apart from that, everything else is like fine. Okay. For the normal square matrix, for all these things, you will not see errors. Just for single row, single column, you'll have to check that separately. Understood? Okay. Now try this. Let's start with strings. Let's discuss that. We have like around 40-45 minutes. So let's complete strings, at least give you some idea so that you can start on the questions, right? I know a few of you have completed it. So you want some things to discuss, right? Some things to begin with. So that is string, right? Okay. So see, what is string? So string is nothing but an array. Sorry. So what is string? String is nothing but an array. Okay. So you can think string is nothing but an array. How is it an array? So array has a lot of properties, right? So for example, if you want to access any index element, does it give in O1 line? Yes, it also does the same thing. So for example, we already know string, right? This is not new. We have already taken a string like s equals to hello. We can take it from input as well. Now, what are the things that are similar between string and array? I'll talk about the memory and all those things in detail, but let's see what's similar in the code wise. Let's talk. Okay. So this is a string variable. Can we access any particular index value? Does it have indexing? Yes. String also follows the same indexing like an array. So index 0 is a like string. Index 0 is the character at index 0. Index 1 is the like index 1 is this, index 2 is this, index 3 is this, index 4 is this. If you print any particular index value, you will get that particular character, right? So system.out.println, how do we access that string index value? We do s.caret 0. Similar to like in case of array list, how we do array list.get and we pass the index. It gives us the value at that particular index. Now, similar to that, doing string in case of string s.caret 0, it will give us the character at that particular index. Okay, so index 0 will gives us 0, index 1 gives us 1, index 2 gives us 2. Okay, so on. Even like some languages like C, they don't have a string explicitly in the initial set of code, right? You can have like studio additional import that can give you string, but initially it doesn't have a string. So in case of like very basic C, where we don't want to do any additional imports, we use character array as a string. Okay, so there is no concept of string, there is no string data type at all. Okay, so we use character array as a string. So wherever we require string, we use simply a character array because that's the same thing, right? Even character arrays has a lot of additional things than string. String has few additional things that character array doesn't. Okay, so there are only two things that you need to know. String builder I'll talk about. We have a separate class for string builder as well. Okay, so that we'll talk about. For now, just focus on string. Okay, so can we find out the length of this? Yes, we can, and there is one difference in finding out the length. So in case of array, you do a.length, you don't put this brackets. In case of string, you need to put these brackets. Okay, now what does how does this two differ? So how does let's say a.length and a.length differ? So what is this? So this is basically here the length is basically a function or a method, or you can call this, you already know function, right? Function or a method. Here this length is basically a property. Okay, so this length is basically a property, or you can think it as like data value of that object. Okay, so you will understand about what property, what data value is in a very detail when you learn about object class and object concept. So this is how it differs. I can give you the terms now. So you already know about function. So this is basically we are calling a function and telling that to give me the result of this function. Okay, and here basically I'm accessing a property that is present in this a variable. Okay, so that's different. You'll understand the like a concrete difference about property and data value when you learn about class and objects. Okay, right now I'm just giving you that these two are different in this way. You will not get questions for this one right now. Okay. Right. Yes. String make function or array make property. Okay, that's it. So now we can use this to find out the like length of array. We can print it. So it will give us what's the length of this string. Okay. Now similar to arrays, strings are also immutable. Okay. So strings are also immutable. So let me write that. Strings are immutable. And here it is even like here the immutability of strings is even stricter than compared to array. So in case of array, you were only the like you are not you'll just the restricted operation was you were not allowed to add characters at the end, you are not allowed to add values at the start, you are not allowed to insert any particular value. Okay, but in case of strings, here you are not even allowed to change any characters in any particular given index of the string. Okay, so let's say you're given any particular like index of the string, and I ask you to update this character, you cannot do it. Okay, it is immutable. There are alternate ways to do it, but you cannot change that string in this particular string itself. Okay, so you cannot update this e in this particular string. We can create a new string and store. Yes, that's the solution for it, but you cannot update this string over here. Okay. Let me do this discussion. Before that, just one last thing to show you over here. So since we know the length, since we know how we can use any particular index value, can we traverse this string like an array? Yes, we can actually traverse this string like an array. So if we want, we can print this string. So system.out.println, and we can do s.caret I. Okay. So this would print the string. If I run this, so this would print here the string in each character by character form. Okay, it's print. Okay. 5e, and then we have hello. Okay, so we just print the string character by character over here. Okay, by using the loop. So we can print it similar to how we can print arrays. We can traverse it, we can access each character, how we got an array, we can get the length. And this is the only operations you need to know on strings. There are a lot of string functions. Okay, so for example, if you want to convert this string into a lowercase string, you have a function for that, right? So you can just do like, for example, s dot to lowercase. Okay, and this will convert the entire string into a string of small alphabets. Okay, so you have a lot of functions on string. So for example, see, it is changing the capital H into small h. Okay, or if you have this as LLO, so it will update, it will figure out which characters are capital S case and it will convert them into lowercase. See, it is doing that. But actually, I'll say you don't need to know too many functions. Okay, I'll tell you the ones that you need to know that you can use. You can use them in code, but you need to know right now the implementation of all the functions. Okay, how these functions are written, what's the logic, how it is working. Okay, so I'll explain you for a few functions, and you'll get the idea of how you can write your own string functions for any operation. For example, let's say tomorrow you forgot how to write this function, or you forgot the name of the function, then you can write that logic yourself. Or if the interviewer asks you that can you implement this logic yourself, or can you like not use this inbuilt function and write that logic, so that also you can do. Okay, so let's check that. Okay, so now here comes the interesting part. So till now I told you the similarities between string and array. So what are the similarities? First thing is you can find out the length. Okay, second thing is you can access the character at any given index, like you do for array. You access the character at you access the like value at any given index of the array. And third similarity was you can traverse the string similar to traversing an array. Okay, will the complexity be same? Yes, its complexity is also going to be same. Okay. So now we saw these are
immutable, sir. Strings and array are also same.
No, there is one difference over here, immutability. I'll just talk coming to that point. Okay, so this is the similarity between them. You can find out the length, you can find out the character at any given index, you can traverse it. So this is the similarity. What is one more similarity? That you cannot update this. It is immutable, but here this is like immutability is little bit different. So what does immutable in case of array means? Okay, so when I told arrays are immutable, what does it mean? So basically, when you create an array and let's say you are storing these values. So when I told arrays are immutable, I meant that you cannot add any index or any new values over here. That you cannot do. You cannot add any new values over here, or you cannot add anything in between. Right? You cannot add increase the size of array. That's what immutability means. You cannot change the size. You cannot add new index or delete any index that already existed, right? So you cannot either increase or the size of array, or you can decrease the size of. Both the operations are not possible. You are not allowed to increase, you are not allowed to decrease. Okay, but you can update any given cell value. So if I tell you to update this 5 to 8, you can do that. But you can write a of 3 is equals to 8. So that will update it, right? You can update it, you can change like any particular index value. Now this update logic, using this update logic, you did a lot of things. You find out the like rotated the array, you did a rotate array, you did reverse array, right? You can swap any two index values, you can do any update on any index value, right? Once you create an array, you can keep on updating it as many times as you want. You did a lot of operations. Now in case of strings, okay, so let's look at the heap. From there also there was a hint about string. So what was the hint? So I told you that there are three parts. One is stack, one is heap, and what was this space known as? String constant pool, right? Focus on this word constant. So did I ever earlier use this word constant? Kahin use kara hai? I've used it, I remember. Where have I used it, word constant? There was a keyword also. I told you how can you make any variables value constant?
Finalizer.
Yes. So we used a final keyword that told us that if I write final int a equals to 5, what does this mean? That I will never change the value of a and it is going to be 5 always. Right? We used this variable in case of switch case where we are not changing the value. We kept its value as 5 always. If we try to ever update this value, JavaScript tells us error that when you declared this variable, you told us that this is final. Now you are trying to update it. No, this is not allowed. So you're not allowed to update any final value. And what we call these kind of variables as? We call these kind of variables as constants. These are known as constant because their values never change. Right? So what is the difference between a variable and a constant? So variables value can be updated. The variables value can be updated, right? It cannot be updated. Okay. So that is the difference between a variable and a constant. Now, what is this string known as? Is it known as a string variable pool? No, it is known as a string constant pool. What does this mean? That the value that you are storing in this string is like a constant, but which is a little bit catch, right? Thoda to different hoga, right? See, so this value is actually a constant. Okay, so that is correct. That part is correct. This value is actually a constant. But what's the small catch, right? Ki kya catch hai, kya different hai yahan pe? So see, now let's sum up this entire story, right? So this value is actually constant. Whenever you create a string, what happens is it asks for, so here creating a string of 5 size, right? So so the fundamental rule of memory, what it was, if you want space, operating system will give you, you need to say the size. Okay. If I want space in stack, in heap, in string constant pool, wherever I want, I need to tell the size, it will give me that space. So if I tell I need 5 bytes, it will give me 5 bytes. If I tell I need 15 bytes, it will give me 15 bytes, but I need to tell the space. Okay. Same logic follows over here. If I tell this that I need these many bytes, okay, so how many bytes I need? So when I'm storing hello, so it is 5 characters and each character is 2 bytes. So I am telling I need 10 bytes of space in total. 10 bytes of space in total from the string constant pool. It will give me 10 bytes of space, and we are using that space to store this hello. Now we are not allowed to update this hello in any way because this is a constant value. Is hello ko hum update nahi kar sakte because ye constant value hai. Okay, this cannot be updated because it is stored in a constant pool. Now what happens when I write s is equals to let's say world? Okay, what would happen when I do this operation? So this is actually allowed, but what is happening is it is not actually updating the string. It is forgetting about this memory. It is getting garbage collected, and we are creating a new memory where we are creating a new string, which is world, and now this S is pointing to this new memory. So it was earlier pointing to this. Now we told that forget about this, let that be garbage collected, let that go to the garbage collection. We'll create a new memory where we'll store this new string, and now S will point to that memory. Okay, so basically if S is a reference, earlier it was pointing to the some memory. If I update it, it will point to some other memory. Okay, we are not allowed to perform any update in the current string. So for due to that reason we cannot change it. Now for coincidentally hello and world are 5 length, but let's say we put hello instead of world we put world code. Okay, so this is a different length string, right? So is there any way you can if you claim 10 bytes, within that 10 bytes can you store the string? No, we cannot store, right? We cannot store within the existing. This was requiring 10 bytes, and we cannot store this new string into 10 bytes, right? Even if we can, we will not be doing that. If and when we are not able, like when we have the string of larger length, we will not be able to do that. So we will ask for a new space. Now, how much amount of space we need? This is 5 plus 5, 10 bytes in total. Sorry, 10 characters into 2 bytes each. So it is 20 bytes in total. So we'll ask for a new space that is 20 bytes. We'll get that new space. We'll store world code. Now S will start pointing to that new space. Okay. Okay. So simplest thing to understand in string is कि see 2 points. ठीक है, दो चीजें याद रखनी है. Firstly, string are immutable. ठीक है. Or you can treat them like constants. So what does this mean? You are not allowed to perform any edit operation. Neither you are allowed to create like add any character at the end. Neither you are allowed to add any character at the start. Neither you are allowed to like update any character in the given string. You are not allowed to do anything. कुछ भी नहीं कर सकते string में. ठीक है. Now what will happen if we do a reassignment or something, or if we do something like this? ठीक है. If we do something like s is equals to hello, we had this string. Or if we do something like this s plus h. So let's say we are allowed to do string concatenation, that is allowed, and we can store that in the same string. So if we do this, what happens? So this is basically actually creating this new string, which is like hello plus a, hello a. Okay? And that is a new space. So if you do operations like this, if you do any update operation, right? Update operation is basically creating a new string. If you do any update operation by doing string concatenation or assigning a new string altogether to the same variable, it will basically create that new string in the new space in memory, and it will store it in the like same reference. Okay. So if you do any edit operation, that's a new string that simply creates a new string. There is nothing that does on the existing string, that gets garbage collected. That memory is not wasted. So we are not wasting memory. We are not duplicating something. We are not having any such logic. We are just creating a new string. No, so okay. So let me clear this confusion. Okay, first tell me understood this. This understood? Okay. Yes. So I'll show you some interesting thing, something that is very interesting. So let's say why string immutable. I'll talk that point. I'll cover that point. Just give me a minute. So let's say this is our A array. Okay. If I run this, where did I define it? So you're getting 10, but now notice the interesting part. ये तो expected था, right? यहाँ पे तो कुछ नहीं कर. But if I print a of 0, that also updated to 10. Now, why did e of 0 update to 10? The entire concept is in the memory concept. So, let's see what is happening. So when we created this array, there was an actual array that was created in memory, which looks like this, okay, which has the values 1, 2, 3. Okay. What was the reference that was pointing to this? A. Okay. Now remember, I told you the concept of call by reference, that until you yourself copy all the element of one array to another array, right? That doesn't create like that will only create a copy. If you don't copy the elements of one array into another array, that is not creating a copy. So for example, if you do this, this is not creating a copy of the array. This is basically creating a reference that is pointing to the same array. So both of them are pointing to the same array currently, and these two variables are reference which are pointing to the same array. Okay, so when you updated p of 0 is equals to 10, what actually happened was the first array also got updated and the second array, like it is the same array, right? There was only one array that got updated. Now, since this array got updated, now when you are trying to access p of 0 or a of 0, both will give you the same result because both of them look at the same memory. There is same one memory that they look and they tell you the result. There was no copy of it that got created, right? Same thing I told you, right? When we studied the concept of call by reference, what did we study over here? If you are passing an array to a function, if I pass this array to a function and that function updates this array, that function is somehow updating this array, so the actual array would get updated, right? It would actually reflect in the same array because no copy of it is getting created. Only time it will not reflect is if a copy gets created. By default, it doesn't create any copy until you yourself copy all the elements. You create this array of new int 3 size, and then you copy each element p of 0 equals to e of 0, p of 1 equals to e of 1. You start putting values. That is the way you create copy. Otherwise, it is going to point to the same memory. Okay. Understood this concept? This we have already seen. Just I'm showing you in the same function, right? I showed you in the function call wala concept where we studied the call by reference wala concept. This is the same thing, right? So no copy of array gets created until you explicitly create the copy. All the references will point to the same memory address. Okay, understood? Is this point clear? Anyone having doubts on this? And this is like this might look like a very small concept, but trust me, when you learn about front end and when you will become a ST2 or a senior engineer, okay, this is the thing you have to work a lot. Okay, so this is like the thing which will cause a lot of, we call it as memory leaks in the code. Okay, so like garbage collection doesn't happen. A lot of things is there. Okay, so you have to work on this a lot to resolve a lot of memory leaks and those. So this is like the fundamental concept of this, and this is it. This small concept causes a very big problem in the performance of your sites. Okay, do you want that idea ki what happens because of this thing? I'll take a minute to explain it. So I'll give you some idea. So see, so I told you right about garbage collection. What is garbage collection? Something that is not used, something that goes out of scope gets garbage collected. Yes, this I told you, right? Garbage collection kya hota hai? Thing like which is not getting used, which is goes out of scope, those things get garbage collected. Now, when does garbage collection happen? So if I told you two scenarios, if we like ourselves would do that garbage collection manually, right? We tell it that we are no more using this space and do a garbage collection on this. For example, when in case of array list, when we are creating a 2x size array, okay, we are creating from 10 to 20 size array, we are telling, right, the logic has this concept of free up this memory space, right? I guess it is the function name is free in Java, right? It would be free or like remove or something like that, or delete, right? Kuch to aisa hoga. Okay, so this like this space would get garbage collected. Now next thing, we can do it manually. Now when it happens automatically, when things got out of scope. So for example, in case of a loop, if you create a variable inside a loop, that gets garbage collected once the loop ends, right? Now assume a scenario you have an array and you want multiple pointers to it, right? You want pointers to it. You are passing it to a lot of functions. You have used it somewhere. You have even stored a reference to it in somewhere else. Now, when this array would get garbage collected, this array would get garbage collected when there is no reference that is pointing to this. When all the references pointing to this goes out of scope. So for example, here there are two references, A goes out of scope and 2 goes out of scope. So it would get garbage collected. Otherwise, like if we do it manually, assuming we are not doing it manually, हम manually नहीं कर रहे हैं, ठीक है, we are not doing it manually, and we are relying कि it will get garbage collected when the variable goes out of scope. And we have stored like its reference in some variable, let's say x, which is never going out of scope. Okay, this variable will never go out of scope if the program keeps on running. It will only go out of scope if the program ends. Okay, when the program ends, everything gets garbage collected. But if the program is running, this x will always point to this variable, this array. So this is a very big problem. If you have any such problem, any such preference, okay, chalo, let me repeat this last part. Dekho. So when this array gets garbage collected, this gets garbage collected when A and B, A and P, both of them go out of scope. A goes out of scope, and B also go out of scope. Okay, both of them go out of scope, this gets garbage collected. Luckily here, both of them go out of scope at the same time when this function ends. So this array is garbage collected. But let's assume there is also another pointer x which is pointing to this array. हमने कहीं तो पास करा है किसी function में which runs forever. ठीक है? So which kind of function it can be? So let's say it is a function which is giving you the like some information है that it is storing. ठीक है? And this variable never goes out of scope. ये variable कभी out of scope जाता ही नहीं है. ठीक है? If the program is running, this variable is always within the scope. ठीक है? This variable is such that if the program is running, it is always within the scope. So this array will never get garbage collected. और कोई भी ऐसा reference हो जाता है that is pointing to the array such that this reference never goes out of scope. So this is basically a blocker because this array will never get garbage collected even though you are not using it. Okay. So we have to ensure that there is no such reference that never goes out of scope, right? If we are done with the logic of array, we don't need that array. So any reference pointing to that should go out of scope, or any reference to that should get garbage collected. Okay. And this causes memory leaks, which causes performance issues. Like if you see any site that is working slow, the 90% of chances are it is having memory leaks. Okay. So it is having, someone has created random arrays which never goes out of scope. It keeps on running, lying in the memory. Okay. Ads on website, right? So that is like, ads is like little bit managed. Google has some garbage collection, they do it well. Okay. How to, yes.
Sir, here you create the P array, sir. P is a array here.
Yes, P is a array. P is a array.
So sir, P of 0 refer to A of 0 and P of 1
yes.
refer to A of 1.
Yes. So if you print this, like if you actually before doing this, if you actually print P's values, right? So before doing this update, if you print P of 0, P of 1, you would see it actually printing A's value. Okay. But here there is only one problem, that this is not copying this array into creating a new copy. It is actually pointing to the same array. Now, if you do update operations on P, it will actually update the original array, not like it doesn't have any other copy to update. So you'll see A array is also getting updated.
No, sir, I told you that that's a P of 0 stored the address of A of 0, and
yes,
P of 1 stored the address of A of 2. Like this.
Yes. So for so if you mean this, right? So for example, so it is storing the same values and the address is also same. So if I, for example, if I print P and A and I run this, you can see both of them are exact same address. There's no difference actually. So in the code num, just that we have created one more reference to that address, and we are treating it like it is just an array, so it is also treated as array, but actually it is same in memory. Is there any way to update P? We need to create a copy then, right? We need to create copy which will be copying every element of A into every element of. So for example, that can be done if you do this, right? So if you do this, you create array of 3 sides, you iterate through this, put P of 0 equals to A of 0, Now this is creating a copy, p of 0 equals to a of 0. If you do like, now this is creating a copy. So for example, now if you check, so this is a new array, this is also a different array. If you update p of 0, a of 0 is not going to get updated. See, so this is having a different address, this is having a different address. When you update p of 0, it is updating, but a of 0 is not updating. Okay. Now I'm coming to string references. Okay, understood about array references? Same concept जो हमने पढ़ा था ना वहाँ पे, we understood that concept of call by reference. So this is that same concept, just that we have used it within the same array. Okay. So but when I create a string using new keyword in ID, it shows some tagline original. Why is it so? It's a difference is creating strings in these two ways. Using new keyword in ID shows some tagline. I'm not sure about that tagline. It might be like environment or ID specific, because here we will not see. Here I don't see that. Okay, chalo. Now talking about string, right? Does it happen in case of string as well? So actually not. So if I create s2 is equals to s, okay, let's print both of them first. S. Let's copy this, let's paste it. So let's change it to s2. Now copy these both and then paste it as s2. Okay. Here update, let's update s2 is equals to world. Now run this. See. So see this. Now here there is a difference in case of string. Okay. So in case of string, even though it is a reference type, right? So that's why I tell that string is very, very special. A string is a very special type. It has a lot of things implemented very differently. Okay. So for example, it doesn't allow us to mutate anything because it is a constant. Okay. Now it follows that constant wala approach, constant ka rules follow karta, it doesn't allow us to update. Now in case of here, we call it as a reference data type, but actually it is not a reference data type when you see this logic. So array was a reference data type, right? When you are updating like creating a new array, putting a, so this was pointing to the same reference, same logical address, same logical address ko point karta tha. Now here s is not having some logical address, it is having a value. So whenever you write s, it means like a normal variable. If you do int a is equals to 5, int b is equals to a. If you change b, a doesn't change, right? If you change b to 10, a will not change because it is not following any reference or any concept like that. It doesn't know anything about that concept. It simply like wherever you write a, it simply puts its value, that is 5, right? Same thing goes over here in case of strings. So when you created s is equals to hello, so it has the value hello. Now when you do s2 is equals to s, it copies the value, not the reference. Okay, this is the value copy. So the value is getting copied, not the reference. Now when you print this, what is going to happen? Firstly, you see hello and hello, both of them print hello, which is fine. But if you update s2, the s string is not going to update. S string is still hello and s2 is going to get updated. Okay. What's the use of pointing towards an array? So basically array is reference by nature, right? So it happens because of the nature of array, we get a is storing the actual logical address, and when you try to store a into something else, you like accidentally store the logical address. You don't store any copy, you don't store any variable, you store the logical address. So here the logical address is getting assigned, right? So the assignment is happening, but not of value, but of logical address. Now, since this P gets the logical address, it has a valid array. When you try to access P, it is accidentally accessing the array still, right? So refer करने का फायदा क्या है? So for example, call by reference is a valid example. So you will not need to do things like this, but you will need to like in case of call by reference, you might need to pass the array to some other function, and you would expect when the function updates the array, your array should get updated, right? So that is the one use case of having a referential thing in case of array. Okay, understood? Understood the difference between string and array. Why am I showing you these differences and similarities? Because this is going to help you see where it is similar, where it is not. Okay, so here it is not, right? Here in case of array, different there was a very big difference when you are updating s2 like a second array. So when you were updating P, the actual A array was updated. But when you update S2, nothing changes on S1. Nothing changes on S. There is nothing. This is a different variable altogether. Huh. When we created P as a reference in array, so it takes the exact same amount of space like to store a reference. So a reference is basically of same size that your data type. In other programming languages, in Java also it would also be same. So this would be like each integer is 4 bytes, so this would be 4 bytes. So P would take 4 bytes in memory, but like it would be pointing to the same address. Okay. Can we do call by value without a loop in array? No, there is no way to pass array by value here. Specifically in Java, there is no way. In other languages, there are ways. In Java, there is no way to do that call by value. You need to create a loop to copy the array and then only you can do it. Okay, so P is a reference array, so it won't take any additional space. So array wise space is not there. Only just to store that address. P is another variable, so that variable will take some amount of space. Ideally, it is the equivalent to the size of the array that you are creating. So if this array is of integer, so integer takes 4 bytes, so the P would take 4 bytes just in memory. So additional only 4 bytes is going to be taken from the memory for creating one reference. If you create 10 references, so each reference would take 4 bytes. The array might have hundreds or thousands of elements. That doesn't matter because no copy of array is getting created. But if you use s equals to no, that doesn't point to the same thing. If you create this as hello and this also as hello, they won't both point to the same thing. So these are two different values. They won't start pointing to the same thing, right? So they have their own constant value that is created. For example, if you create two variables a and b, and both store the value 5, so you won't see, right? They will have their same separate memory spaces which is storing 5. Right, same if you create hello in S and hello in again S2, so they would have again their separate memory spaces to store this, right? They won't have a shared memory to store this, and later if you change, only one of them changes. That cannot happen. If anyone has shared memory, for example array, if you update any using any one of the reference, all the same array gets updated, so all the other reference will also see the updated value. The string like it won't take more space. It's just that previous spaces are getting garbage collected, right? So few operations become expensive. So I'll talk about the expensive operations now. What these like what this internal structure of string changes for us, right? Which operations become costly, which operations are cheap. Yeah, so in costly means in terms of time, right? Which is order n, which is order 1, or like, and why these operations are order n. Okay. Why do we use double instead of equals method? It checks whether they are pointing to the same logical address or not. Now there is an interesting question. For example, this, right? So when will references be equal? In case of strings, the references like there is one way to actually do it using reference. Let me show you this. So for example, let's say we do this and we check this. Let's say if s is equals to s2 and we print system.out.println hello. Let's print equal. Okay, let's run this. Okay, I'm running this. So I've created a string and I'm checking whether they're equal. So what does it print? It prints they are equal because right now it is comparing their value. Okay, now look at it how we can differ this. So we can, since we can also create it as a reference type, so we can store this new string hello, and we can copy this thing and paste it over here. Run this. Sorry. Okay, we don't see any output, right? If I put else part, you'll see that they are not equal. So this is a very like strange difference over here. Very difficult to explain this. I think I'll explain. So now see, now it is printing not equal. Now what happened, right? Kya change ho gaya, right? So I see. So what happened actually was now when you create string using new string, this equal to comparison is actually comparing reference. Okay. So now when you're getting using new string, so new keyword kya karta hai, right? Simple words, right? Simply let's understand what does new keyword do. So whenever you use new, you are simply asking new memory. Okay. New simply gives you new memory. New का काम ही यही है कि it gives you new memory. If you ever use the new keyword, if you ever write new in front of something, it gives you new memory. From where? From the heap. Okay. So if whenever you are writing like int a is equals to new int something, okay, what is happening? You are asking new memory, right? New memory. Now, what is happening over here? Now, since you have created string using new, what is happening is it is creating two like it is getting two new values, two new addresses, two new space from the memory, and it is getting two new references pointing to this. Now, when you compare using this equal to, it is actually comparing the reference. Okay. Let me do one thing. Let me also uncomment this and.
So here the address are different, sir.
Here the address are different. They are pointing to different address. Okay. But I can also prove that in case of when you just do assignment normal, they are also pointing to different address. How? We just saw, right? In the old case also they were pointing to different address. When we stored this as S, and what would happen if we do this? We create a new string S and we just do this operation. Now see, it is telling equal. Okay. Now I know this is very difficult and this is very tricky over here. That's why I say string is very special. See what is happening. I'll explain you this. Okay. So there are three scenarios, right? Let me write all the three scenarios. Okay. So let me write it in three parts. It is very confusing. It can even confuse a senior engineer as well. So don't worry. Okay. If you are confused, then it is completely fine. So there are three scenarios. One is you do string hello, S2 is equals to S. Second scenario is you do S is equals to new string hello, and S2 is equals to new string hello. And the last case is you do S is equals to new string hello, and here you do S2 is equals to S. Okay. Now quickly, which ones are equal, which ones are not equal? So if you try to do this, you'll see equal. If you try to do this, you will see equal. If you try to do this, you will see not equal. Okay. Now, why does this happen? What is the reason for all the three cases? Okay, kya reason hai? So firstly, when you are storing this value, right? When you are storing this value, the comparison is actually comparing value. This is a value comparison. There is no address, there is no reference, there is nothing such concept. It is just like writing int a is equals to 5, b is equals to 5, and you are checking if a equals to b. Okay, so this is simple to doing this. What you get? You will get equal. You get this as true. This exact thing is happening over here. The values are getting compared. There is no concept of reference. Okay, concept of reference will come when you start using the new keyword. New keyword use karoge, then it will have the concept of reference. Then it will start comparing reference. So when you use the new keyword over here, what happened? Two new memory addresses, two new references. It is actually comparing reference. So S and S2 reference are not equal because they two point to different address, and like the references are different. Okay, their addresses are different, their logical address is different. So these two are different references. So that is not going to be equal. Now, when you do this, when you are doing this operation, what is actually happening is you created one memory. Okay, and here you are actually storing that S in S2. Okay. Okay. Also, let me show you one more thing in the last case. So let's say you stored this S in S2 and you do S2 dot update. Okay, S2 is equals to world. You run this. Okay. So you see S is getting S is still hello. S2 just changed to world. Is it updating S as well? So no, it is not updating S. So no matter whatever you do, the second variable S2 can never update S. Okay. The second variable S2 can never update S because they are different in memory. वो constant pool में दोनों different है. Okay, see here, this is an example. Even though here you are getting equal, they are pointing to the same reference. We have created it using the reference based strategy. Now S2 you are updating to world. Now even though you like print both the values, you see S is still hello and S2 is world, and it is telling that they are not equal. Okay. And since you updated this, now this is a new reference and it is not equal. Okay. So if you do an update operation, that changes its reference, that changes, creates a new string that stores it. But if you don't do, this is pointing to the same reference, but there is nothing you can do on string, right? Why you need this reference? This reference is of no use. Once you update this, it will just start create a new string, store it in here. In case of array, there was some sense, right? कुछ तो sense बनता था. इस p को update करेंगे. If you update p, it will update the actual array. But here, if you update s2, एक नया string बना के s2 में store कर देगा. Right, it will create a new string and store it in S2. It will not update S, right? So this reference is a useless reference. You will get this as equal, but this has no usage. You cannot use it in any way to do anything on S. Okay, it will just be like to read S. If you perform any update operation, that will store a new reference and do it. Okay. I know this is very confusing, super confusing. I'll say this is like the most confusing concept that's there in reference and strings. This will take a time to digest कि क्या हो रहा है, right? ये क्या है? Like हर एक case में there is some new logic that is following. Like looks like that chemistry class where the teacher used to teach some chemistry law, and then it used to say that this is exception, that this is exception, this is exception. Yes, there is no exceptions over here. It's just that the behavior is different depending on the situation of how your S and S2 is coming. Okay. See, I'll put it in simple words, plain simple words. Okay. इसको ऐसे समझो. Okay. The first thing when you do this, treat it like variable. जो normal variable बना रहे, the variable that you are creating till now, A, B, X, Y, Z, whatever variable you are creating, which stored simple value. So here the value comparison is happening. Here what is getting compared? Why you are seeing equal? Because value is getting compared. Okay. Why you see not equal over here? Because here, since you created it using new keyword, the equal to will compare reference. Equal to compare references since you created it using equal. Since you created it using new keyword. Same goes over here. Here the equal to compares references since you have created the first string using new keyword and you're storing it. So here you get equal because it compares the references. But once you update a string, that will just create a new string, put it in here. So every dynamic changes. If you update this, so this is the new string. It was earlier equal. Now since it is comparing value, it will always look for value. If the value matches, it tells you equal. If the value doesn't match, it doesn't tell you equal. In case of here, when you're using the new keyword, you are creating a new memory. So now they are new memory. If you update S2, that again will ask for a new memory, store, create that and store it in S2. So that again, every time it's a new memory. So no matter whatever you do, you will always get not equal. Okay. When you're doing this, so this is the only case where S2 was pointing to S reference. This is the only scenario you could get another reference to S until you update it. If you anywhere write S2 is equals to new string something, so that like immediately creates a new reference. But even if you do this S2 equals to hello, this will create a new like space in memory which will store hello, and this will be a new reference. So now you would start getting not equal. So if I run this, you would start getting not equal because neither the reference is equal nor the value is equal. हाँ, अपडेट से पहले रेफरेंस सेम था, अपडेट के बाद बदल जाएगी. यस, सो अपडेट से पहले रेफरेंस वाज इक्वल एंड लेटर इट इज. हाँ, hello h1, hello h2 is hello, s is equal to hello, s2 is equal to hello. That's same because this compares value. There is no reference concept over here. That is like normal variable where the value comparison is happening. That means there is no
please
difference in all
explain the third case, sir.
ठीक है. In the third case, ठीक है, first title में this case you everyone got first case and second case. There is no doubts in the first and the second case. First and second case are simple, right? You have value comparison. Second case is two different arrays, right? Two second bit out है, ठीक है. See, second case में what is happening is you are creating two strings, two new keywords. So when the first new keyword happens, so you see a new string which is hello. When the second new keyword runs, you see another string which is hello. Two different strings, right? So S and S2. Okay. So they are not going to be equal, right? Their references are different. Two are different memory addresses. They're storing everything is different. So that is going to tell you not equal. And it is here the comparison also happen on references because you have created using new keyword. Even though both of them are storing the same value, here the comparison is not on value. The comparison is using references. Okay. Now the last case is this.
Sir,
Yes.
sir, but double equal to operator always checks for always compares reference, right? So it's just that in first case, S and S2 are both pointing to same hello. That's why it is giving result equal, no?
Yes. So if it so in the first case, it is actually comparing value. See, in the first case, there is no concept of reference. So when you do things like this, so let's say we have not done this. This is the third case. So when you do something like S is equals to hello, and S2 is equals to hello. So here the comparison will be by value. There is no reference. They two have their own space in memory. We can prove it. So for example, if you update S2, S is not going to get updated. S is going to remain same, right? So here the updation is not going to reflect. So see, S2 is only getting updated. S doesn't update. So they are different thing in memory, right? Only thing is when you compare in equal, so it is telling you not equal because S2 is updated. But if even if you don't update it, right? So here now it will compare with value and it will give you equal. So when you do things like this, so here you can treat it like normal variable, right? It is just normal variable which is comparing value. Okay. Acha. Now, if this is little bit too much confusing for this, I know this is very confusing and this is like very difficult to digest as well. So for this, Java has given you one easier approach. Okay. So no matter however you create string, Java told you that don't use that equal to compare it. Okay. So you will never see equal to compare it because the string might be created using new keyword. It might be created using like direct assignment. So there can be a number of ways, right? Now like you don't know how it is created, how it is coming. So best way is to use this. So this always tells you whether it is equal or not. Let me copy the part from here. Okay. So now let's say whenever you do this operation, let's say we are creating using this, you run this operation. So s dot equals. Okay. So now if you run this, it will just compare for the value. It is telling equal. If these values are not equal, let's say this is hello 1, so it will tell you not equal. Okay. It would just compare for values. It doesn't compare for reference, or it doesn't know how these strings were created. Now when you do it using this, so let's say if you create the string using this and the second string using another new. Okay. So in the case of when you were doing equal to, these was getting that these two are not equal. But when you will do it using this equals, this will tell you that these two are equal because the values are equal, right? If you have these two references, even though they are different reference, they point everything different. Since their values are equal, this tells you this is equal. So this equal keyword always tells you a comparison by value. Doesn't know anything about reference. Doesn't look anything on how the string came from. Okay, so this equal keyword always compares things by value, and this is something which you should use while comparing strings, not this. And this is the reason, but you should know what happens when you use equals to, what's the problems, right? Why it happens, right? Why it is happening. The new keyword to start. So when you like don't use new keyword, it is actually like similar to creating a variable, right? It is asking some space from memory that this is the string I want to store. It memory gives that much amount of space, it stores that string. Okay. That when we create strings in it checks in string constant pool that's there or not, and then it returns a reference instead of creating this. No, I don't think this is this ever happens, right? This never happens. There might be some optimization caching it Java might be doing, but it always creates a new memory for this. Okay, because when you update it, right, how will so it will it should be updating it, right? Okay. New is not looking any useful. So for example, this exists, you just need to know, but you don't need to use it for now. Okay, so to cut the entire long story short, there is a lot of again memory things that I'll talk about in detail tomorrow. Okay, I'll give you idea. There is like still string is little bit thoda sa memory. We have a lot of concepts over here, but apart from this, string is very simple, right? So apart from this, string is very simple. So let's do a one small operation on string that will solve a lot of questions for you that you will need in a lot of questions. And now so you can start doing questions. Okay. So the first like initial questions you'll get, right? Count the number of vowels in string, count the number of constants in string, count the number of given character. Let's say you're given a character L, count the number of characters. So that is similar to doing array operation, right? You write a loop that will traverse through the string and you count how many times E is present, how many times A is present, how many times any character is present, how many vowels you have, how many constants you have, how many digits you have. You also know already about the ASCII concept. So this is a simple character which you can use to compare it by whether it is capital character, whether it is small character or not, right? So that all things you can do, right? So I'll give you one small concept that might be useful. I'll solve few questions tomorrow on string, so that will give you idea. One small concept. Okay. So let's say this is a string hello. Okay. Now let's say I give you a simple problem is to find out a new string which is the first three characters of this string. Can you do it? A string which is having, let's say, the first three characters of the string or any string. Or you're given any string and you have to find a result string which is the first three characters of this. Think. Yes, you can run a loop that runs from I equals to 0, I is less than 3 or 2, I less than 3, so 0, 1, 2, I plus plus. What you can do is result is equals to result plus s dot caret I. My efficient result. VCHEL. Okay. Space wise, both of them are very different, right? And this, so for like, for example, integer 1, 2, 3, 4, 5, it is 4 bytes, but string to 1, 2, 3, 4, 5 is 10 bytes, right? So it is like string is 6 byte additional as compared to that integer, 4 and 10 bytes. So space wise, it is different. Got it? So this we call as substring, right? This part is known as substring. How can you figure out a substring of this? Now this has a lot of usage, right? This substring is very useful. Understood? So this is string concatenation. Here we are doing string concatenation, right? There is a function to do this as well that also does the exact same work, which is s dot substring. So instead of doing this, if you use this function directly, so that will give you the same result, right? If you do s dot substring and you just pass it like the 0 to 3, it will give you the first three index, excluding, so this second index, excluding this, whatever value it has, it gives you. So 0, 1, 2, the values in the index 0, 1, 2, it gives you that. Okay. Okay. Now this has a lot of usage. Right. That's the whole string thing, right? String concatenation, everything. Now I'll talk about the time wise. Time wise, I've not talked anything about what string operations take, what's the complexity of it. Space wise, I gave you some idea how this thing works, like how garbage collection would happen, when it happens, why it happens. So time wise, I'll talk about that. That time wise, I'll go in detail. How can you optimize it? Which operations take time? Why do we? Why string is very bad at time, right? String is a very bad data structure for considering time, right? Very bad data structure. But then string builder again has its own complication. So there is a lot of things that's there. So we'll talk about that. So we'll understand them in detail tomorrow. Achha. Now use these concepts, right? Try to solve the basic questions on strings like traverse a string, print count any character, print count vowels, count constants. I guess those will be the questions that's there in the first assignment, something like that, right? So you can try out those questions. You would be definitely should be able to solve them. So if you go over here, camel case, toggle case, inverse camel case, compressed string, shuffle, compressed string. So this was an interview question that I got once. So you can think of this distinct palindromic substring. Okay, this might be okay. You have to find out a palindrome of a string, so that again would be done by string coordination. Count words in a given string, so you need to count the spaces and just plus one. So this one, this one is a very famous interview question, compressed string. Okay, this is a very famous interview question. This has a lot of implications in memory, in performance, in code optimizations, in image bundling, in streaming. Everywhere this concept is used. This is used in a lot of places. So this is like asked in interviews very frequently. Okay, so take a good string panagram. So now you can try these questions. You'll get some idea. Okay, I know we will struggle a lot because there is like a lot of concepts that we need to know. Okay, I gave you the basic idea of string. You can try this. Complete all the 2D arrays and array list switch cases questions. If you have still more questions to practice, you can practice from the gym. That I would always say to do that. We need one more class to complete strings. I'll talk about string functions in details. Okay. Acha. Now just do one small thing. Okay. Just figure out one small thing for today. Okay. Take this as an assignment from me. Try to insert a character at a given index in string. Okay. How will you do this operation? So how will you perform this operation? Try to figure this out. Okay, so if you are given a character, you already have a string, and you are given an index where you have to insert this character. How will you do this? And the hint is you need to use something from substring. You'll get the idea. So do we using methods in string? We said in array they ask without using methods. In case of strings also, interviewers ask you to implement the methods, right? So substrings, there are a few methods that you can use, lowercase, uppercase, but you need to know implementation. I'll talk about the implementation of these methods. Very easy, right? So this is the entire substring method. Is it difficult to figure this out? Was it difficult? Is the same complexity that this substring method gives? Yes. The complexity wise also it is same, and it is not very difficult to figure the logic out. Here, very simple logic, right? Very small logic. We'll write the logic of a lot of or I'll write the logic of at least 5 or 6 of methods. We'll get the idea of how all the other methods are implemented. Okay. Triplet sum. Array list questions we'll discuss tomorrow. I guess you have done everything. Only spiral and array list questions are remaining. Okay. Now repeat the question. So here basically you're given a string and a character. You have to insert this character at a given index in the string. So let's say the string is hello and the character given is G and the index is, let's say, 3. So you have to insert this character at the index 3. So 0, 1, 2, 3. Okay, so this is how your final string should look like. Now how will you perform this? Think. Yes, so that's the correct. Right, few of you got the solutions right away.
The substring concept used, sir, here.
Yes, you can use substring over here. Yes, that's the only way to do it actually. Okay.
Divided the string into 2 parts and then put the characters.
Divide it into 2 parts, put the character, concatenate it to get the final string. Yes. Like that's the only way to add a insert in between of the string, or and if you figure this out, try to update a character in the string. Okay. If you figure this out, don't worry about time. Okay. Now, how will you do this update operation? You don't need any methods. You have to write this logic yourself. There is no method that is required. You already know all the concepts. Okay, I guarantee that all the concept that you need to do these 2 operations, you already know that. You don't need any additional concept to perform these 2 operations. Very simple operations. So just throw a tricky, it won't strike to you instantly, but if you think, you'll get to easily get it what I'm talking about. Okay, so let me paste this notes in the chat. Not replace, right? Don't use that replace function. Okay, write that logic yourself. Okay. Tomorrow I'll talk about string methods. I'll talk about the time complexities of string. I'll talk about I'll solve few more questions. I'll solve questions from the string. Okay, I'll give you a few more days to solve it yourselves. Today you can start trying. So at least the easy ones you can solve them. Okay. The ones that requires just traversal counting or basic. So for example, count words. So that is a very simple operation. You just need to count the spaces plus 1. That's the number of words in a string, right? So all those easy questions you can try. You can complete at least them. Complete array list and string switch cases question. The remaining time utilize to solve 2D arrays questions from the gym. You saw like we did 2D arrays complicated questions as well. Go through those solutions. Try to now implement them yourselves. Okay. Do these things today. Tomorrow we'll again start with string, and tomorrow we'll go in very depth of string, understand time and everything about string. Okay. Any doubts? At one place, or just one place, just insert that character at one place. Okay. I have shared the notes. Please paste it in a WhatsApp groups. I'll share it in this as well. Using a loop of unknown size from user. How to take array list using loops of unknown size. So if you want to take a array of unknown size, you need to write some condition where the loop would end, right? So you can just write an infinite loop, keep on taking array list inputs into array list. Once that condition hits, you can use break to break outside the loop, right? Tomorrow, any change in time? New Year? No, same time, right? That's even not a holiday for us. So there's no New Year something. Yes, while true is an infinite loop, that would work. But you need to write break, right? Until it, otherwise it would be time limit exceed. Okay. Thank you everyone. See you all tomorrow. Bye bye. Good night. Take care.